gain knowledge from the great industry experts. Before getting into today's tech talk, I want to say something to you. It is never a mistake to make.
Okay. I want all of you, when you go out of the session, know a few basic concepts of what DynamoDB is, when you should use DynamoDB, how does it work, and what is the pricing model of DynamoDB, and what are the use cases of it, right? So if you understand all of these, I think that's the success of the session. Okay. So this is the topic. So we're just going to talk about DynamoDB, a bit of scaling of DynamoDB. To introduce myself, Sridevi Murugayan. I have 20 plus years of IT experience. So I've been working with Cognizant for a few years, not few years, for a long term, 14 years, and then with Status for 4-5 years, and then right now into one of the BFS company. So I'm not disclose that because there's an organization policy not to disclose, but you can definitely find it on the LinkedIn. Okay, so I've been part of AWS UG Chennai, and I'm one of the data heroes, as you mentioned. So before I talk too much into the topic, a brief introduction of what community is, because our community is a place where people can share and learn from each other. Light off, Manuma. Thank you. So these are some of the pictures of what I got from community, okay? So why I'm standing here in front of you is because of community. So there are a lot of communities, so feel free to get yourself attached to some of the communities, learn and share, because community is a place where you can speak openly and you can also learn openly, okay? There is no strings attached to joining a community. So please get yourself attached to any of the community you love based on the we have got few sessions from reInvent also. These are international sessions as well. So we have a lot of opportunities to travel, collaborate across all. Why I'm doing this today? Because this is a community event and we have got a lot of community presence. So feel free to get yourself attached, learn and share from each other. Okay? So anybody knows how Amazon Prime works? What is the database behind Amazon Prime? All of you use Amazon Prime? Anybody who doesn't use it? Don't use Amazon Prime. Oh my God. Oh, that's good. But do you know what is the database behind that? DynamoDB, okay? So earlier it used to be Oracle and they are now migrating all the backend operations to DynamoDB. So DynamoDB is predominantly for your millisecond latencies. If you have applications that you want a millisecond response, then DynamoDB is the place to go. But I would not say DynamoDB is the only database that you should prefer. There are a lot of other databases. AWS has a spectrum of databases. Okay, so you have relational databases. I'll share the slides with all of you, okay? Don't worry, I'll share, there's nothing new in this. All of these are available in the internet, I'll share it with all of you, okay? So there are so many databases. You have relational databases, you have NoSQL databases, you have ledger databases, you have Cassandra and MongoDB compatible databases, which is another form of NoSQL, right? So why does AWS provide so many databases? Awesome, yeah. He's a regular friend, you know, so he knows all the answers and all the questions. So there are different use cases. You cannot use the same database for all your use cases. There are use cases where you have to use only relational databases, and there are use cases where you can use NoSQL databases, time series, ledger. So there are a lot of use cases, and you have to choosely the databases. That's the reason we just wanted you to give an insight on what different databases are and how do you choose different databases. Okay, so if your use case is millisecond response time, if you want your response time to be very, very quick, then DynamoDB is the place to go. And there are a few other aspects that you may have to know when you are choosing DynamoDB as well. I'll just go through that. But there are a lot of applications which leverage more than one database. It's not that you have to always settle with one database. We have used DynamoDB with Postgres, we have used DynamoDB with Redshift, and we have used DynamoDB with Aurora. So there are a lot of combinations you can pick and choose when you are designing your applications. I heard some of you using MongoDB, some of you using relational databases. So there are use cases for each and every database here, and that's the reason AWS is providing all of these purpose-built databases for you. Got it? Yeah. Let me know if I'm going a little fast, because I have a lot of content to cover, so I'm just going a little fast, okay? So what is a SQL database versus NoSQL database? Structured query. Great. Correct. Super. So SQLs, how do you see, how is your SQL database? It will be like an Excel. You have tables, you have rows, you have columns, and every row should have the same column, right? For example, if you have a people or if you are a user, so user should have first name, last name, email, address. So every single row in that table will have the same data repeated for different users. So that is how your SQL table is organized, right? And SQLs also have something called integrities, right? Your foreign keys, primary keys. Why do you have foreign keys, primary keys? Why do we need that? Why do we have to normalize? Correct. So for underlying cause for normalization is storage optimization, right? You don't want to replicate your data across different tables. That is why you have come up with a concept called normalization, and that is the base for all your SQL database. But when it comes to NoSQL, you cannot do joins, okay? That's the ground rule, no joins. So all your data should be accessed from the same table only, okay? So why storage is not a big concern nowadays? Any guesses? Cloud, correct. Because cloud cost is very much reduced. When SQL was discovered in 1980s, storage was huge, right? Actually the time and cost to procure a server when I started my journey in 2003 was at least 6 months to buy a server. Okay, so we have to wait for 6 months, but nowadays provisioning a SQL server, it will take just 5 minutes, right? So that is the speed of cloud, right? So your cost is optimized, your time to procure is optimized, so cost is no more a concern, storage is no more a concern. What we need is the performance. So that is where your NoSQL is actually will help you. Okay, so here your constraint is only compute. So you have to be focusing on compute. As everybody said, no relationships. NoSQL will not have a table-like structure. All you need is a key. Okay, one key, and your data can be anything. You can have any number of attributes to your data. It's a JSON file. So if you say for customer ID Sridevi, you can have one record with all your personal details, another record with all your professional details. The same table can have any format of data except your primary key should be unique. So that's the only constraint you should have when you're defining your NoSQL. Am I with everybody? Clear? Okay, another key thing when you are designing your NoSQL database is access pattern. Okay, this is very, very critical. I want everybody to understand this. When you are defining your NoSQL, you should know how you are persisting your data, one, and how you want to retrieve your data. If you don't know this pattern, then NoSQL is going to be a very costly option for you. Okay, for example, if you are storing user information, you should know how you want to store the data. What is your primary key? So are you going to retrieve the data based on your primary key? If you are not retrieving your data based on your primary key, you are going to pay additional cost. Okay, so that is why we say access pattern is very critical when you are defining your NoSQL databases. Is this point clear? Because this is very, very important. I have been involved in some of the cost optimization for DynamoDB, and one main cause for the costing of DynamoDB is not finding your access patterns right when you are designing your table. So that's the only thing you may have to design when you are designing your DynamoDB tables. So what are the access patterns? For example, if you are defining a product table, you will have product ID, product name, product category, and some status. So how do you want to retrieve the data from the database? So you should know all of those patterns. Okay, so just define that when you are defining your DynamoDB. Okay, so what is Amazon DynamoDB? So we've been talking so much about NoSQL now. So it is actually a key value database. As I said, you should have a key, and the value can be a JSON document. It can be anything you want to put for the particular data. And it is single-digit millisecond latency, as I told you. And recently, the Amazon Prime, I think they have recorded 129 million requests per second for the Prime Day. Okay, so that was the latency that your DynamoDB can provide for the Prime Day last year. Okay, so it can handle so many requests because it is architected in that way. Okay. Okay, some of the use cases. So you can use it for serverless if you're interested in building a serverless application, so you can just go with everything serverless here. So you just start with S3 API gateway and your Lambda processing your data and storing it in your DynamoDB. So this is your serverless, and you can also use it for microservices architecture. Same, if you are using analytics, kinesis analytics, and all of those, you can store it to DynamoDB because DynamoDB is serverless, so it comes as part of your serverless stack. Okay, context set. Any question? All good? Okay, so how do you define your DynamoDB? So as I said, DynamoDB, you have to define your primary key. I think that is the only thing that you have to define, your partition key. And rest of your attribute, if you see, every table has different items, okay? So different attributes here. You don't have to have the same set of attributes for every record in your table. Okay, it can be different. So every record can have different attributes, okay? You can say first row having a name of a person, their designation, and all of those. And second row can have for the same person his salary, his date of birth, all of those information. So every record can be having a different set of input arguments. Okay, it's not the same set of arguments that every record will have. Okay, and there is one thing, maximum item size in DynamoDB. Item is a record, so maximum is 400 KB. This is another thing which you have to think when you are storing a blob data. So we don't recommend storing a blob data in DynamoDB. So if you have some images or videos to be stored, even Amazon for that matter, they store it in S3 and reference it from DynamoDB. They don't store any data in DynamoDB, so it's only 400 KB per record. Okay, so that's another thing which you may have to consider. Okay, so how does it work? So you can have one primary key, or you can also have a composite key. I'll show this in a demo, okay? I don't want to talk too much on that. So your table can have a primary, your primary key can be just one key, or it can be a composite key, a partition key and a sort key combination. Sort key is optional, your partition key is mandatory, okay? So this is how your record works, okay? So DynamoDB is always replicated across 3 regions. Your record is replicated across 3 regions. So for example, if you have a record, right? Your order ID is your partition key, okay? And you are inserting the data into your DynamoDB. How does it work? So what happens is your first step, your order ID 1, right? That value of 1 is hashed into some value. Okay, so based on that value, the data is pushed into one of the partition in one of the AZ. Okay, so here it goes to AZB, and it is persisted into host 5. And similarly, it is replicated into the other 2 zones. Okay, so that is how your data is replicated to 3 different regions. Okay, so every single data you insert is replicated across 3 regions for your high availability reasons. Okay, so every record, your hash value of your partition key, right? It is inserted based on, this is your partition key value, and it is hash, and based on your hash value, it will be into one of the partitions. Okay, just for your information, each partition in DynamoDB is 10 GB max. Okay, it cannot go beyond 10 GB. So your data is organized into chunks of 10 GB. You can have 10 TB data also, but it is split into 10 GB each. Okay, this is all for your performance consideration when you have to consider tuning. So you have to think about this. Okay, so access pattern, your partition tuning, all of this happens because of your 10 GB partition only. Okay. Okay, how can you manage DynamoDB? There are 2 modes of operation. You can have on-demand or provision capacity. So you can say this is my provision capacity of WCUs and RCUs. I'll tell you in a bit what is WCU and RCU. But you can say how much you want, or you can go with on-demand, where DynamoDB will automatically provision the WCUs and RCUs for you. There are 2 modes of provisioning for you. Okay. Okay, so I told you there are 2 WCUs and RCUs, which is write capacity units and read capacity units. So what is write capacity unit and read capacity unit? So your DynamoDB is not charged based on your running time and all. How is Lambda charged? Anybody know? Based on the runtime, right? How is EC2 charged? Uptime of the instance. But DynamoDB is charged based on the WCUs and RCUs you consume. Okay, so what is WCU? It's a math. I don't want to talk about too much of math, but you can refer it from the document itself. So 1 WCU is required to write 1 KB data. If you are writing to your DynamoDB 1 KB of data, then you need 1 WCU. Similarly, you need RCU to read data, read capacity units. So with 1 read capacity, you will be able to read 4 KB of data. So when you are defining your WCUs and RCUs, this is a small math that you may have to do. So for example, if you have an application which writes 100 records per second, then you need 100 WCUs, right? Similarly, how do you want to retrieve the data? You have to define your RCUs. There is a very small calculator that is available when you are defining a database in DynamoDB itself. But as a best practice, I would say, when you are running your workload, leave it on demand for a couple of months, observe the pattern, and then define your RCUs and WCUs so that it is correct. Have auto-scaling enabled also so that it can go between a range, okay? Giving a set RCU and WCU when you begin with may be a little tricky, and we may be running out of errors sometimes, okay? That's one of the tips we had. Okay, so before moving this, I'll ask a question, okay? So I was telling you that you can search based on your partition key only, right? Correct? Is that correct? Okay. So when you're providing a DynamoDB, you can search based only on your partition key, okay? So if there are use cases where you want to search based on other columns, other attributes, then you have to define your index, okay? So index is, so when you have defined a table with user ID as your partition key, and next time you want to change it to name, you want to search by name, then you can go and define your indexes, okay? There are two types of index, global secondary index and local secondary index, that you can create for a different access pattern to the same table, okay? So that is why we have this index concept. And a word of caution here again, so when you create index, especially the global secondary index, what happens behind the scenes is your table is actually duplicated. So entire data will be copied and your search order will be changed. Okay, so there will be cost associated. So if you are creating many index for every access pattern, what you are doing is you are duplicating the cost on your DynamoDB table. So this is another thing you may have to be aware of when you are defining your DynamoDB table. Okay, so local secondary index doesn't cost so much. It is actually a partition key will be the same in your local secondary index, so it doesn't cost much. But your global secondary index are very costly. Not costly, it will little double based on your usage actually. Okay, and I'll explain how you create global secondary index. There are a lot of optimizations you can do when you're creating it. Okay. Okay, this is how it works in action. So there are these components, right? So you have request router, a storage node, partition, and auto admin. So these are different components of your DynamoDB behind the scenes. This is not directly available in any of the documents. This is available in one of these reinvent videos. I put the reference links down there, okay? You can just go through this. This was by Rick Hullinen, who was DynamoDB owner at that point of time. So he gave us insights on how DynamoDB works behind the scenes, right? So you have a user who is connecting through HTTP request, and in DynamoDB we have a concept called request router. So request router will talk to partition metadata system, and it will know where your data resides. And based on that information, it will be routing your request to the storage nodes. So these are the components behind the scenes which works for you to retrieve the right data. So here, right, you directly go and hit the partition. You don't go search your data like other databases. You don't go and search a huge list of index, because here your partition metadata system stores your index information. So your partition ID or indexing, right? So that index from 0 to 100, it is in this partition. And 101 to 200, it is in this partition. So that information is stored in your partition metadata system. Okay, so based on what request ID you give, it will directly go and hit that partition, get the data for you. That is why it is giving you millisecond response latency. Okay, is that architecture clear? So these are the core components which is working behind the scenes. I'll share the deck with the organizers, maybe if they share it with you. The link is down behind. Okay, so this is, you can also search. This was by Rick Hullinen in 2018 reInvent. Okay. Okay, I think this is not very critical. I'll go to the demo. This is how your DynamoDB console looks like, okay? So here, it's very simple. I'm just doing it from console, so it's very, very simple to create a table, DynamoDB. So DynamoDB does not have a concept called databases, okay? All you have to create is only tables. You don't have to go create a database and tables. Just go straight, create tables. So click on create table. Okay, you have to give a name for your table. And as I said, you have a partition key and sort key. Sort key is optional, so we'll just select a partition key, some user ID or user email, whatever you want. So this should be unique, and the data type. Okay. So how it works is, right, when you give partition key, your search is based on your partition key only. But if you give sort key will sort your data based on the values it has. Okay. So that's additional thing sort key will give. And from a combination perspective, if you're defining a table just with partition key, then your partition key should be unique. And if you are using the combination, then the combination of partition key and sort key should be unique. You can have for the same user, you can say, okay, this is my home address, and for the same user, you can say, this is my business address, and this is my other address, whatever you want to give, right? So you can repeat the partition key if you have two keys defined. Okay, so that's the benefit of having sort key. So it works for the product, right? If you have a product and status, right? So if you have status of, for the same product, if you have multiple status, then you have to define both the keys, partition key and sort key. But for user data, we generally go with just partition key is enough. Okay? And then you have a default setting. So in default setting, it comes with a read capacity of 5 and write capacity of 5. Okay, it's a default, and auto scaling is on by default. Okay, so these are the few things I was talking about. So when you go for customized settings, you have a small capacity calculator, I told you, right? So what is your input average item size? This is your record. What is your data size, right? One record size. If I say 4 KB, okay, and how many items you want to read per second and write per second? I'm saying 1. Then it says you need a read capacity unit of 1 and write capacity unit of 4, and this is your estimated monthly cost. This is a small calculator you can use in case if you want to understand how much your application is going to cost. Okay. So then I'm just saying provisioned and on-demand. There are two modes. If you select on on-demand, you need not define any number. So DynamoDB automatically scales for you. Okay, but if you go for provisioned, you can say what is your of your auto scaling. Without auto scaling, you can just say what is your provision read capacity, write capacity units. And if you enable auto scaling, you can say what is your minimum and what is your maximum. So what is auto scaling? Anybody wants to take it? Yeah. So you can increase or decrease based on your usage, right? So it starts with, if I say it starts with 1 and ends with 10, then it goes between that range. So when there is no interaction, it will just be at 1, and if you use it, it will go up to 10. And real time, you have seen 1,000 RCUs, 10,000 RCUs also. Okay, if your use case is really huge, it can go beyond that also. But for demo, I'm just giving 1 to 10. And you can say when you want to kick your auto scaling. When should your auto scaling kick, right? That is the 70%. When your DynamoDB is 70% utilized, kickstart your auto scaling. Until then, it will be your previous number. Okay, so now I'm just giving 1 and 5. And then you can create your index. As I said, you can create a local index and global index. So here, if you're creating local index, you can only change the sort key. You cannot change the partition key. Partition key is the same for your local secondary index. So this is for a different access pattern. As I said, if you want to search based on a different field, then you'll go for a different search pattern. And then the attribute projections are critical. Here, if you see, right, there are all keys and include, right? There you can say what columns you want to project on your secondary index. If you need not project all your columns from one main table to other tables, so that is why you select whatever you need. Okay. Similarly, for global secondary index, I'm not creating any. You have to provide a different partition key. Okay, so that is the difference between your local and global secondary index. So you have to define a completely different partition key, and this will create a copy of your data. Your entire data will be copied into a different index. So I'm not creating that, and I'll just go ahead, and from an encryption perspective, you have all these 3 options. You can use AWS managed key, customer managed key, or Amazon owned key. And create table. Okay, so this is how you create your table. Any question on how you create your table? So I've created some tables already, so I'll just take one of the tables it's creating. So this is how your data looks like. So if you see here, right, so ID is my partition key for this table. So here if you see, I have organization information, employee information and customer information on the same table. So that is what I was saying, right? If you have to design this in a relational database, you'll be designing 3 different tables. But here you can put everything in a single table and you can just access based on your prefix. So you have prefix with org and employee and cust, right? You can use that and search your data. So that is how it works. Okay. And from scanning, how do you query the data? There are 2 options. You can scan data or query data. Scan will scan your entire table. There is no condition and it is very costly. So you should avoid scanning. And query is what will search by keys. Okay. And the query will search by partition key. And your partition key is actually equal to operator. You cannot do a like operator on your query. Okay. So that is why I was saying your access pattern is critical, because you need your proper key. You cannot just like this, like search and all will not work for your DynamoDB. You have to give your proper key. And scan, you can use like search. There are like search for scan. Okay. How are we doing on time? $20. Oh, that's good. I don't think I need so much time. So how your data looks like is in a JSON view, right? I'll not show form view. This is how your data looks like, okay? So use your ID and all of your fields. Okay, that is why, because it is more of a JSON document, you can store your data in any form. Okay, and then our table got created. So here you'll be seeing all your index, and you can create index after your table is created also. And then there is a concept called global tables. So global tables is more of if you want to have your same DynamoDB access across different regions, right? You have created in one region in AWS, US East 1. And if you want to have the same table in US East 2 or in Mumbai region or Hyderabad region, then you can go and create a global index, and you can start reading data from that region. Instead of you connecting from one region to another region, you can create your global tables. That's the purpose of having your global tables. And there are backup option and export and import option. So all of these are required for your DR strategy and your backup strategy. And there is also a concept called streams, where if you want to stream your data from DynamoDB into Kinesis, then you can enable your streams, because if you have a streaming use case where somebody is playing the game and if you want to stream your data to some system and store the data, then you can capture the data in DynamoDB, stream it directly from DynamoDB to Kinesis, and from there store it to S3 and do some analytics on top of it as well. Okay, you can use that for your streams. And any changes you want to do after you create a table, it's still possible. You can go to additional settings and you can edit all of these. Okay. Any question? I know I'm dumping a lot of information on you, but any question? There are a lot of options you see on the site, right? I'm not talking about everything, but I'll let you explore. And if there are questions, please come back to me, and definitely I'm happy to explain. But there are too many things that you can do with DynamoDB. I'm just giving the basics so that you get an understanding of what it is. Okay. And see, there is another thing called DAX. DAX is your caching layer for DynamoDB. You can enable that as well, so it will cache your data. Instead of you hitting DynamoDB every time, you can create DAX and do that. Okay. So Particle is more of a query editor. If you want to query your data like a SQL on DynamoDB, then you can use the Particle query. Okay, so that is why you have here. Okay, so this is how you can query the data. If you provide the right value, you will be getting the response to that. So that is why you have this Particle editor. All right. Any question? I think I'm almost done with what I wanted to. So these actually I showed the demo of how you do it via console, right? So these are how you create VR using your Boto 3 or CLI. So this is with CLI. So I've just created a sample table And this is just how do you load your sample data to DynamoDB, or you can also use your SDKs to insert data into your DynamoDB. Okay, so this is backup option if demo doesn't work. Okay, before moving on to quiz, any question? Quiz is very simple. It's very easy questions, but any question before that? Everybody can create a table right away. Go, yeah, go ahead. My LinkedIn, no? Sridevi Murugayan. So there is only one last name, so you can all find it. So yeah. See, there is I showed you the KMS and all of those, right? So you can encrypt your data there. Okay, so that is data encryption, right? At table, at rest security, you can do it with your data encryption there. So rest all is HTTP request. So whatever it is not like service to service request. So this is an internet service. Okay, it's not like internal service where you connect. So it is on HTTP request. So you have to restrict your access based on your user roles and IAM roles actually. Yes, there is a cost. So you see, there is whenever you enable a cache, there is always a cost, right? There is also a cost of invoking your DynamoDB directly, right? So every time you hit your DynamoDB, there is an RCU and WCU being used, right? So that is going to have some cost. So you have to compare and contrast the cost between using a DAX versus using your RCU or WCU. So that cost optimization you have to do, and if your DynamoDB is hit multiple times for the same request, for example, then it is worth using your DAX. But if your queries are very different and every time it hits a different tables, then you may not go to DAX. Okay, DAX is more of your 3 servers sitting in front of you caching your data. Okay, so there's going to be cost associated with that data actually. Any question? You can use it, but it will be your custom implementation. So you have to create your cache and you have to put the data into it and you can retrieve it from there, right? So any application caching can still work, but you have to implement it. Here all you have to do is you have to create a DAX cluster and you point to the DynamoDB. There is nothing, you will not say, oh, put this data here, put this data there. Generally in Redis you have to put that, right? You have to put it in the cache. So session and all, you need not maintain that. But here it does it for you. You can definitely do that. It's like an application session, right? So Redis also you can do, but you should be building it, you should be managing it. But here it is managed for you. Any other question? No? All good? But I'll be around here maybe until 3, 4. I have a lot of my friends presenting, so I'll be here. Any question, anytime related to data analytics, a bit of GenAI, I can respond to all of your questions, Bedrock, all of those. Okay? So, okay, we'll move on to the quiz. We have time? Another 5 minutes. I have goodies only for top 3, okay? Let me know if you can access it. It's going to be very simple. I'm not going to ask something different from internet. All whatever I spoke only you'll be getting today. All scanned. Achu no, okay, Ramya no. And somebody else. So no, you're not playing. Are you all done? I'm going to stop sharing. Okay, shall we start? All good? 15 minutes, sir. I need another 5 minutes. All good? Shall I start? Okay. You're not playing. Okay, we'll start. We already have 35 people. And I have only 3 goodies, I don't want to disappoint many. So we'll start. Fastest fingers, quickly. 30 seconds, which too much. All done? Wow. Everybody except one. Awesome. So my purpose solved, at least you know what is DynmoDB. Okay, next question. What, network is not good? Oh, I heard that. I showed this in the picture and all, okay? You should not forget this. Where is leaderboard? We'll see the leaderboard. Okay. Only 60 people, oh my god. Okay, multiple region is also an answer, but I wanted the specific answer, okay? So, good. Answer எல்லாம் leak பண்றீங்க நீ. Who's Nitin? Nitin here. Good. Okay, next question. We have 2 more. Read the options and just answer, because I don't think I have mentioned it as it is in the response. I have mentioned it in a different way. Oh my god. You lost it, huh? Read the question once. Read the question and then response, please. Respond. Read the options also. Wow. Full turn. Oh my god. Okay. Last question. This is very easy. Want to try? Done. 5 minutes இருக்கும். இல்ல நீ தான் கொடுக்க போற. நீ சபரி. Good, good. Awesome. So who's Mohit? Please come, and I request Sabri to give the goodie. So all of us are representing UG here, so I just thought maybe. Vijay photo எடுங்க Vijay. ஒரு நிமிஷம் I'll just change the background alone. Okay, the second, I didn't see the name, sorry about that. The second, Anish. Oh, you were sitting together. Hey, Ramya, come, you do the one. Let's just Azar. One shot. Change the background. So all of these goodies are from you. Azar? All right. Thank you so much. And yeah, if there are any questions around, please do reach out to me. Thank you.
Thank you, ma'am, for a wonderful session on DynamoDB. I'm sure the audience would have found it quite helpful. And I request Dr. Balamurugan sir to hand over a gift and a memento to our CJ ma'am. Let's give a round of applause. Thank you. Thank you, ma'am, for joining us.
Thoughtful of you. Thank you so much.
So I take immense pleasure in introducing our next speaker to you. She is one of the top data engineering voices at LinkedIn, and I'm so honored to see her live with us. So please welcome Ms. Abhinaya Devi SV for a session on S3, Amazon S3. Thank you.
Hi everyone. Before starting the session, we can have some games. All you know connections, right? Connection game. Yeah. The first one. It's not about AWS. It's general. So everyone knows this. No. Yeah, you know the answer already. The next one, it's all about AWS services. From yesterday, we are seeing so many AWS services. You can connect. Easy to, yes. Yeah, AWS influences don't answer. Then this, yeah, this, yeah, correct. This one, yeah. Yeah, I'm going to talk about Amazon S3. This is one basic topic because 2 days back only I got to know I'm a replacement of other speaker. So Amazon S3, simple storage service. It's a short talk only. So don't expect much from me. And also I'm presenting for the first time. If I stuck in between, apologies. Okay. My name is Abhinaya Devi SV. People go by Abhi, and I'm on data enthusiast. I'm very active in LinkedIn. You can follow me on LinkedIn and Medium. I write about data engineering and data analytics, and small hands-on about data engineering and data analytics. You can find me on LinkedIn and Medium. Abhinaya SV is my user. You can scan the QR code. You can get me. Today's agenda is about what is S3 features, use cases, and we can talk about objects, buckets, how we can efficiently store the data, storage classes, and how we can securely store the data, and about policies, versioning, and how to do the basic hands-on, like hosting one static website. We can have a demo, and what is S3? Everyone knows, I think. Storing files in the cloud. It is one of the first serverless storage in AWS. The one efficient way of storing the data, that is organization use S3 for storing the data and files. It is one of the intelligent storage service, we can say. Other AWS services also using S3 as an storage. We can see about what all the features about. So when we come to cloud, it's a common features, right? Durability, availability, low latency, and scalability. Many abilities for cloud, we can say. When I started with cloud, I'm much confused about durability, availability, scalability. Many much terms are there. So we can say we can relate with one real-time example of each. What's durability is about? Anyone know what's durability? What? Yeah, we can say what's durability is about is how much the data we can store efficiently and securely. Durability is about how much the data resilient to attacks. That is about durability. In Tamil we can say எவ்வளோ அடிச்சாலும் தாங்குவோம்டா அது மாதிரி S3ங்கிறது. So it's having 99.999 percentage, like 11 nines is there for S3. So we can say 100% I'm available today. Like the durability is about 99, 11 nines is there. Just you can remember the number. I'm having quiz at last. And the availability is about uptime, how much the data can be available to the end user. We can say like I'm going to request to the website, means it should be available to me every time, right? So likewise, the availability is about the uptime of the storage, and the scalability. So how the availability can be always uptime means we can say about Google Drive is there, right? We are uploading images there. So if any disaster recovery occurs to the one of the server, means you are not able to retrieve the data. Okay, it is going to have multiple copies. Replication of data should be there. As Sridevi told, like 3 availability zones are there, right? So likewise, it will be available in different availability zone, and different regions will be there. So the availability is very high, and if certainly availability zones are high, low latency, how much frequent we can get the data in the it is about frequency of data we can access. Then scalability is about we can scale up and scale down the services and resources, we can say. Then S3 is one serverless storage, right? We don't need to bother about the infrastructure and storage and all. Whatever the storage is about, we can upload terabytes of data and gigabytes of data. We can upload many storage as much we can. It can scale, and infrastructure it can take care of. And the next one, what are the use cases S3 is having? Means we can store the images, and we can, as we know, Instagram, Facebook, many social medias are there. We are uploading plenty of data, images daily. So it can store images and videos and then log files. Okay, today I'm two people are working in the project, and one of the person is updating project today. Other person is having changing the data tomorrow. Means it is having the log files history also in S3, and backup and archive. It is one of the best storage for backup and archive. And data analytics. When we come to data analytics, so okay, data engineer also use S3. Data analytics, data analyst also use S3 as an storage, and data scientists also get the data from S3. So, and then content distribution, we can get the data from S3. And the next one, what are the other services use S3 as some storage services? Means Amazon easy to use S3 for storing and accessing the data, and Amazon Lambda to trigger serverless functions. So when we subscribe to YouTube channel, we are getting notification, right? So how we are uploading the data to S3. So S3 Lambda function triggers the notification to us. Like when we are uploading the data, it is okay. Abhi, you uploaded the data. So you are okay. You are one of my subscriber. Means you are going to get the notification like with the Lambda function. Then Amazon ODS use Amazon Redshift. Most of the database using S3 as an storage. And then we can have one real-time example how backend S3 works. Okay, we are almost everyone will be in Instagram. Okay, I'm having account and I'm uploading the image today. How everyone knows image or data or everything we are going to store in the database only. Okay, how S3 comes here? So S3, I'm uploading one image or video, means it is going to store in the database in the backend. So the program, how it will be programmed is, okay, if the image or video comes into the backend, you can store it in the S3. S3 is, if we upload the image, means it is going to have one link. S3 link. The S3 link, that is the metadata. The metadata is going to store in the database. It is like the table will be having like user ID, username, and user uploaded the picture or the timestamp, and the where the image is going to store is S3. S3 will be having the database have the link of the S3. That is how the backend works. And we can have how the behind scene S3 store the files and data. The first one is it is okay, I'm going to store the images in my laptop, means I'm going to have one folder right. So likewise the S3 will have one folder, that is the top level folder, we can say that is a bucket. The basic term when we come to S3 is bucket. The basic term we can say what the S3 can store is, it is going to store in the bucket. The bucket name should be is globally unique. If I am creating AWS SJIT folder name is, you can't create the same bucket name in the console. It should be globally unique. The bucket name should be. So in the free account we can have 100 buckets, and we can increase by requesting the bucket services by increasing. If we request thousands of buckets also, it can provide based on our need. So how the bucket stores the data? So it is not going to store as the image format or video format. It is going to store the store the files in the data form. If I upload file also, it is going to store as an object, and image also it is going to store as an object. Whatever I am uploading PDF for, the file type is, it is going to store as an object only. So the object refers to the fundamental entity of the S3 is object, and how the image is going to have is, so okay, image AWS SGIT is the key value, and the image, the information is the value here. So this is how the bucket stores the data. And then we can go for storage classes. The storage classes is the efficient way of cost optimization. So it is the breakdown of high to low. The S3 standard is having the highest cost, and standard S3 cache deep archive is the lowest cost in the storage classes. So we can explain about each of the storage classes. S3 standard, if you want to retrieve the data daily, means we can go for S3 standard. It is having the high durability, availability for frequently accessed data can be stored in the S3 standard. And S3 standard IA, infrequent access. Okay, in Instagram we are having the story archive, right? The archive, the story archive, okay, 1 year back, also in the storage archive, okay, on this day you had the memory, it will be displayed, right? That's how S3 standard IA is. It will be have in one storage, but we don't use it frequently. That is S3 standard IA. This is lower cost compared to S3 standard. And then S3 one zone IA is, it is having a single availability zone. Okay, zone is like a high, different zones are available in the AWS. So this storage class is going to have only one storage. If the data loss means we can't retrieve the data. If it is going to attack by any cyber attacks or anything, means this is going to be vanished away. And then S3 intelligent tiling, we don't care about the storage classes. We don't care. If we choose the S3 intelligent tiling, means it is going to have the, okay, I'm uploading 100 gigabytes of data today, means it is going to choose one of the S3 standard. Okay, another day I'm uploading other things, means it will have the, we don't care about which storage class we need to choose there. And then S3 Clasher and Clasher Deep Archive is low. Both are low cost. The Clasher is we don't need for 5 to 6 years. This is used by organization for compliance purpose. It will have transaction and like what we can say, S3 Clasher. They will store for audit purposes and all. S3 Clasher will be used. It is like 5 years or 6 years. We don't need it, but if we need it, we should have the data in speed manner, right? So S3 Clasher is used for this. S3 Clasher Deep Archive we never used for it. Its retrieval cost is high. S3, but storage cost is less. If we want the retrieval, means the S3 Clasher Deep Archive is high. And this is the one flowchart of storage classes. If you need immediate access, okay. S means how frequent you need it. Okay, daily you need it, means you can go for standard. Infrequent, okay, infrequent means we don't need it as much as frequent, means we can go for that is 2 zones available. Like multi availability zone is for okay, we can go for standard IA. Only one availability zone we need, means we can go for one zone IA. Then rarely we need the data, means Glacier instant is there, and here you come, means I don't need the data as much frequent. That is means we have to Glacier flexible and Glacier deep archive. And how frequently you need it? Rarely we need it, means we can go for Glacier flexible, and almost never I don't need it for my things, means Glacier deep archive we can choose. This will be reduce the cost. Okay. And then life cycle policy in storage S3 is available. It is an automated process. What the life cycle policy is about, it will automate object transition between the object. If I'm having an object in bucket means I will allocate some rules to it. That is what life cycle policy is. If I'm not using the object for 30 to 40 days means it will be automatically moved to the standard IA zone. Okay, it will have some minimum amount of days to move the storage classes to different zones. That is what life cycle policy is about. And resource policy is for defining the permission to the bucket resources. Okay, I'm having one image folder in the bucket means who all can use the images. It can be public or it can be only used for some specific people. Okay, in the organization, Abhi is there, Ramya is there, means who can access the resources. That is what resource policy is about. It will be we can format that on JSON format. And this is what resource policy is. It will have this format. Okay, the principle is okay, I'm a user, and effect is okay, I can allow the which folder we can allow the user means she can able to get the object, get the images, videos and files over in the S3 bucket. So what the folder we get access to, many folders will be there in S3 bucket. So specific folder only I can able to access it. That's what resource policy is about. So we can differentiate what's IAM and what's resource policy. I am also going to give the access and permission to the user, and resource policy is also the same, right? So what's the main difference? IAM is going to have the user access. So okay, Abhi is going to use S3 and EC2 means it is going to give only S3 and EC2 access to me. When resource policy is about what the resource present in the bucket is, we can give the user to the particular resource. That is what IAM policy and resource policy is. So example, we can say IAM policy allows an admin to delete user comments, while resource policy restrict the public access to Instagram image. Okay, image folder is there means it will restrict the public access to specific users. That's what IAM and resource policy difference is about. So versioning is we can preserve all the histories of the version. If two developers are working in the project, we can, okay, one day the one developer is changing the code, the other day the other person is changing the HTML code, means it will have the version, history of things in the versioning. It will have the MFA to I'm going to access the code means changing the code or deleting the resources in the bucket means it will have multi-factor authentication also. It will it's for security purpose. And what are the key takeaways we can get from Amazon S3? The basic thing is Amazon S3 is one cloud storage service where data is going to store in the bucket as a folder. Each bucket can have numerous objects. We can save numerous objects in the S3 bucket. It supports versioning and safeguarding against accidental data loss also. And we can have one demo. I'm having a video. If you are going to AWS console and click the AWS S3 bucket, means it's going to have this like structure, and the bucket name we can it should be unique globally. You should do the bucket name. You can't able to do the bucket name unique the same as the other user. So this is for other things. I enable the versioning there, and other things as a default. I have unblocked the block public access because if I host the what it is static website, means I can't able to see the static website publicly, so I unchecked the block access there. So I should acknowledge whether it should be publicly available or not. I'm uploading one static website HTML page. Yeah. So a HTML page and the image file I have uploaded, and then that's it about it. I can upload. We can choose the storage class. If we are having storage class, we need to choose means we can choose it instantly. So now I have to configure the resource policies. So in the permission tab, there will be a resource policy. Okay, before that, it should be publicly available means we should enable the static website hosting here. You can do the static website for your resume templates and all here. You can upload it. So it's going to have one two HTML files. Index document is the front end page. If our HTML page is not available, means we can configure one error.html also there. And then bucket policies. I'm going to do. So this is the one I can allow, and what action means all the action it can be performed, and resources I need to change the resource name there. What current that HTML file URL we need to give here resource, and so I have copied and pasted the resource here, and save the changes. It can be publicly available now. So we can have the URL and paste it in Google means we can able to see the what website I have created. That's it. So here is the object URL present. So that's what it is. If I paste the URL there, I can able to see the static website hosting. That's it. I think I didn't record that. Sorry. We can have one quiz. That's a basic quiz only. All. Can go for it. Bucket name in Amazon S3 should not be unique. Good. That too. 4%. Bhargavi, many people have the top five. Abhiram, Amarnath, Karthik. Huh? Abhiram, right? Okay. The next question, how will be the data stored in AWS S3? That's why I kept okay, bucket, object, okay. How will be the data stored in the object format only, na? Okay, okay. I should have the AWS S3 bucket. I should have the question. Okay. Again, Abhiram, Mamati, Anjana. I don't know how to pronounce it. Pradeep. How much percentage the AWS S3 stands for its durability? So 11 ions, the first. Okay, that's it. So Abhiram won, Mamati Anjana, and who is that? I don't know name. Pradeep. That's it. Thank you.
Um, Thank you, ma'am, for a wonderful session. I'm sure it was very, very beneficial for the participants. You explained the intricacies of S3 very nicely. Thank you. It's a pleasure to have you here. And now I request Dr. Balasubramaniam sir to felicitate our speaker with gifts and whatever. Ma'am? Okay. Please give a round of applause. Once again, thank you, ma'am, for coming here. Our next speaker needs no introduction. He is very well known in our AWS, and especially in the serverless community. I personally met him at AWS, in serverless days in Bangalore. He's a very supportive person, and I'm pretty sure lots of you people here have already been benefited from him, and I personally benefited from him. So it's a pleasure to have you, sir. Let me now invite Mr. John Zachariah Noel to speak on AWS Application Composer. Thank you.
Hi everyone, good morning. Did you guys eat your breakfast? So, good morning. So, have you heard about serverless? Have you built anything on serverless? No? Yes? So, it's a mix of no and yes. Cool. Before I get into the topic, just a little quick introduction of who I am. I'm Jones Zachariah. I'm a senior developer advocate at Freshworks. I'm a senior developer advocate at Freshworks, AWS Serverless Hero. I co-organize AWS UG Bangalore, and I write a lot about serverless. I write my own blog about serverless and newsletter on serverless. I co-run a podcast as well around AWS Cloud and serverless. If you would like to connect with me, you could use the QR code and you can connect with me on different socials. Today, I'll talk to you about infrastructure as code and importance of infrastructure as code and how you could build infrastructure as code using Application Composer. Recently in reInvent, Application Composer was launched with IDE experience with VS Code. So I'll be demonstrating that. So before further ado, let's get started about the session. If you like a lot of memes, I do have a few memes and GIFs around in the presentation. So any Iron Man fans in here? Awesome. So all of you remember the first Iron Man movie when he was locked in a cave and he built his own arc reactor, right? So similarly, few years back, when you were trying to build serverless applications, it was in a similar fashion because serverless is distributed amongst different services, and when you had to do it, you had to write your own YAML templates, you had to go on the console like how Sridevi was demonstrating DynamoDB, right? You had to provision DynamoDB table from console or using CloudFormation and all of these things. You had to handheld a lot of things, so you felt it like you were in a cave, just like Iron Man, built your own arc reactor out of the cave. So today, as we go along, there are a lot of concepts like infrastructure as code and a lot of things that's been evolving. And the way how you get it with infrastructure as code is amazing. The reason being, infrastructure as code. Anyone you heard about infrastructure as code? Okay. So what is infrastructure as code? Okay. That's you just rephrase the whole sentence, but okay. Any more questions? Any automation of? That's right. So when you talk about infrastructure as code, your whole there's one file that defines what are the different services that you use, what are the different resources that you have, and it helps you automating in provisioning these different resources across multiple environments. Why is it important? Because you can't always go to console, you can't always go and provision different resources with the right configurations. So infrastructure as code really helps you with building a lot of serverless applications and also a lot of applications in general on AWS Cloud. So when you're doing it with infrastructure as code, there's a template that defines what are the different resources, how are you defining it, what are the configurations that it needs. Say for example, if you're provisioning a Lambda function, what's the name of Lambda function, what's the runtime that you use, what's the architecture of the Lambda function, and so many different configurations. Some of them that you need is available as parameters where, be it in terms of if you're using CloudFormation natively, you would have to write the code. And today, a lot of dev tools are available with infrastructure as code that help you with provisioning all these resources in a smoother experience. And I'll be talking a lot about it in terms of how Application Composer helps you. But infrastructure as code is basically a file that defines the complete resources. So infrastructure as code is something that we use in our developer workflows. So when I call developer workflows, what is developer workflows is something like when you're trying to build an application, You build it on your local machine, you commit it to GitHub. After it's committed to GitHub, you have different automations that are running, be it for sanity check, then deploying it to a dev environment. After dev, you merge it to a different branch, it goes into a testing environment or a staging environment, and then merging it to another branch, it'll be probably in a production environment. So when you're doing it in a developer workflow, infrastructure as code really helps you a lot. And why is it? Because it fastens the process of deploying these resources across multiple different environments, and also ensuring that the same configurations are consistent across different environments. And when you're working with this, you're not manually provisioning it. You'll have to define the infrastructure as code at one time, probably in the source code where you have it, but afterwards it's just enabling and deploying it on different environments that you have. And when you do it, it's just a simple command that you run, or it's an automation that you run. So when you're doing it with serverless, there are different offerings for infrastructure as code today available. Be it, I just wanted to categorize in terms of how do you do it with infrastructure as code, be it with YAML templates. There are things like Terraform, there are things like SAM CLI, and then there's a lot of things with serverless framework where you are defining a YAML template. Then there's programming constructs, be it like CDK and Wing Amped. A lot of these things which help you with a programming construct that's there, programming language construct that is there. So today we'll focus on YAML templates, but there are a lot of options available with respect to how you define your infrastructure as code. So any of these have you used? Have you come across these names? Yes? No? Okay, awesome. So today I'll be talking specifically about SAM template and how it syncs well with application composer. So when I talk about YAML template, and I was talking about, hey, there's one file that defines a lot of resources. I guess it's not very readable, but there are two different images here. One is an image of a Lambda function and an API gateway, and there's another image of a template with two Lambda functions and a DynamoDB and an API gateway. So when you want to just deploy 3 resources on AWS, you have to write a long code. And this is the YAML template that you have to write as developers. So would you like to write such long codes? No? So these codes are not really good for developers. Instead, it's good for automations and for your workflows specifically. And when you're talking about YAML templates, one thing that it really is a pain is before getting into the YAML template, you often do a architecture diagram of what are the different resources that you use, and during the course of development, it can go out of sync with your architecture diagram. And the other one is that you will have too many configurations that's there in your YAML template. Probably at times there are multiple resources with different configurations. Say for instance, you have 2 different Lambda functions. One runtime is Python, the other runtime is Node.js. So by mistake, if you just go and change the configuration vice versa, it is going to be a haywalk when you deploy it on AWS Cloud. So too many configurations can be overwhelming and can lead to a lot of human errors when you're trying to push it to your GitHub and all of the automations to kick in. So YAML templates is good for automations, but when you're trying to build it, it's a lot of friction in terms of, hey, when I'm trying to build a simple application, I have to write a lot of code. It's too much work for me. So what do we have today is Application Composer, which was launched 2 years back in reInvent 2022 when it went into beta. So what is Application Composer is, it's basically a visual design of your infrastructure as code. When I was showing you the YAML template, so you could, with Application Composer, what you could do is you could just drag and drop all of these resources. Say for example, you have a Lambda function, API gateway, DynamoDB, any of the other resources that you use, you could just drag and drop them. add the configurations that you need. You could make the connections between these resources. Say, for example, API gateway has to talk to Lambda function has to talk to DynamoDB. You could just make the connections, and application composer will generate the IAM policies that it needs, the permissions that it needs, the integration, be it things like VTL code or anything such, is being generated by application composer. So you know what your architecture is, you know what you want to build, you can just drag drop all of these things, and you already have a YAML template. So that's about application composer. And when you're building application composer, it uses the standard and the best practices, using infrastructure as code, using the best practices that are there for security, using the best practices that are there for even defining the way how you do it with different resources. So why do you need application composer is because you can visually build, and when you're building, you're not only building it but also creating an architecture diagram at the same time. Because when you want to use architecture diagram, most of the time you try to go to things like different tools that are available today, and you draw them, and then you understand, okay, this is my flow of events, this is my flow of data, all of those such things. But with application composer, you could do it right at the application composer console. So when you're working with application composer, the best part about it is that you know what your resources are, and you're just dragging and dropping them. I have a demo later on which shows you about how it's done. And also it generates a SAM template. So in case you're using it on AWS console, the SAM template is available. You could use the SAM template, you could copy it, you could paste it in your local code base and run. And also with Chrome browser, Google Chrome browser, application composer can immediately in real time sync with a local folder that's there in your file storage. So basically you can drag and drop, and it synchronizes the file into your local source. So you don't have to download it or copy it or anything such. But all that said, that is just until 2023 reInvent, where AWS launched a VS Code integration for application composer, where right from your IDE, VS Code, you could drag and drop all of these things. It generates the file. It's in your IDE. You don't even have to go to AWS console. And it works, starting off with reInvent 2022 when it was initially launched. It was focused on serverless application, but as the days went by, it started supporting all the resources on CloudFormation. So basically, you can use application composer for any workload that you want to build on AWS. So I have a quick demo. So what I'm doing is I'm going to my VS Code, and I created an empty template, template.yaml, where I just went in. So you can see that there is an icon right on the top. Turn off the lights. Off. Is this visible? Good. So you can see that there is an icon right on the top, where you just have to click that icon in your VS Code, where it launches application composer inside of your VS Code. So what it does is basically mimics the whole web console of application composer on your VS Code, and there are tons of resources, 1,000+ resources that are there, because all of the CloudFormation resources are supported on application composer. So for this demo, what I'm doing is I'm using step functions, where I'm invoking Bedrock to just generate a random story. And using that story, I'm just storing it on DynamoDB. So I'm creating a step functions uh, workflow right from Application Composer. So I'm just defining the, by default, it creates a Lambda task, and I'm removing all of the defaults for my demo. And also defining that my state machine should be defined as a JSON file, and saving it. And as soon as I save, you can see that there was a JSON file that got created in my local machine with the Lambda task. So, and then there's the template.yaml with the state machine definition. At reInvent 2023, AWS launched step functions integration with Application Composer. So basically, inside of Application Composer, you could navigate to Workflow Studio from step functions and define your complete workflow. Here I'm using Amazon Bedrock and invoking Claude model. So I added the invoke model API of Bedrock. I'm choosing my model, and then I have to define the parameter that the API needs. So I just add a prompt and tell that, hey, tell me a fun story about Marvel characters who are using infrastructure as code for your service applications. So just to play around with Bedrock and how generative AI generates a fun story about Marvel characters using infrastructure as code. So that's the prompt that I'm giving Bedrock, and defining the tokens to be 2K. I saved my workflow, and the same is being reflected in my JSON file locally. Back to the Workflow Studio. Once the Bedrock API returns a response with the story, I want to store it on my DynamoDB table. So I'm essentially doing DynamoDB put item and saying it should be an SDK integration. There is a DynamoDB table name, and I'm making it a parameter from CloudFormation. So I'm just adding it as with dollar and parenthesis. I'm changing the key structure so that I'm using the DynamoDB ID for partition key, which is an UUID. So I'm using intrinsic functions to generate that UUID. And also the story that's there that Bedrock generates, I'm storing it. So I'm using the different parameters. So to reference it from the previous task, you would have to use dollar to reference it as a variable. I'm doing that with response. So when I save it and going back to Bedrock, I'm adding that response as a parameter that Bedrock should write the response to. I save my state machine, and when I go back into my application composer, there's a state machine, and there are different tasks that I'm using. Bedrock and DynamoDB is reflected in application composer and in my state machine JSON file. Now that DynamoDB is there, we are doing a put item, but the DynamoDB is not provisioned. So with application composer, I'm choosing DynamoDB, adding it. I'm defining the partition key, the table name is there. So I'm using, again going back into my state machine definition and referencing my DynamoDB table name to my state machine. This is because when the DynamoDB table is deployed, I'll have to get the name and on to reference it as a table name for my put item. So Application Composer supports referencing different resources when you're working with different resources on your template YAML, because most of the times when you're deploying these, you would have to reference it to a specific resource in a specific environment, be it in a specific region or in a AWS account. So what I'm doing is, when this script is being deployed, whenever this gets deployed, the DynamoDB table that it generates and creates is the table that I'll have to reference in my state machine. So I'm adding the definition. And one catch here is that Application Composer generated most of the IAM policies that it needs, but the state machine policies are not added, because step functions does not generate a execution role with all the resources that you add. So what I'm doing is I'm going back to my YAML template and modifying the IAM policy. So you can see that you can see that when I added statement, there's Cloud Whisperer running in my machine. So I've enabled Cloud Whisperer. It has prompted me based on the resources that YAML template holds. It's a DynamoDB and it needs all the access for that DynamoDB table. So it prompts me all those things, but for my state machine, I just require put item. And after the DynamoDB permission is added, I have to also add permission for my Bedrock API from step functions. So invoke model, and also resource is that specific Claude model from Bedrock. So I'm adding the on for Claude model, Claude 2.1. Okay. So now that the template is created and all of the resources are done, what we'll have to do is we'll have to use this template and deploy it to our AWS account, right? And to do this, because it's a SAM template, we could use SAM CLI commands that is there, be it things like SAM sync or SAM deploy. In this case, I'm using SAM sync so that whenever I make a change again, it will automatically sync to my AWS account. So to do that, I use SAM sync. I define a stack name. And SAM CLI will validate the template that is there, build the needed artifacts. Once that is done, it'll give me a confirmation in terms of what are the resources that it's going to deploy. So you can see that under the hood, CloudFormation stack is created with the different resources like DynamoDB table, my log group got created, and a lot of other resources with step functions will be getting created soon. So you can see that in real time, all of these resources that were there, I just dragged and dropped it using Application Composer right in my IDE. I didn't even have to switch the windows to be it a browser or anything such. Just out of my IDE, drag and drop, the template was created, used SAM command to deploy it to my AWS account, and yes, with that, it's deployed to my AWS account. It's that easy. So I went from an Iron Man who was stuck in cave, building my serverless applications, to Iron Man owning I don't know how many mark suits that he has. So many mark suits just so easily with similarly how you could do it is with application composer, infrastructure as code, and code whisperer of course. So you saw that all of these resources were deployed. Let's just check the execution of the state machine on my AWS account. So the deployments are successful, so it's created a step function workflow and the DynamoDB table. What I'm doing is I'm invoking step function execution manually. You could see Bedrock API got invoked. All the definitions as per the definition from my infrastructure as code. Once Bedrock API is successfully executed, there's a story that's been generated, and that story is also stored into DynamoDB table. Is this fun to do? So, yes. Yeah, and there are a couple of things that you have to keep in mind when you are using Application Composer is that since Application Composer generates the SAM template, you would have to have infrastructure as code knowledge beforehand because you may have to validate if it's the right resource, or you may have to make some tweaks like I did in the demo, right? I had to make some tweaks for my IAM policy. So you need a infrastructure as code knowledge for Application Composer, and identifying what are the configurations that you need is also the key. The other part is that with Application Composer on your ID, you need to make an authentication with your AWS account using Builder ID. So using AWS Toolkit, you would have to first authenticate yourself, and then you will be able to use Application Composer, Code Whisperer, and a lot of these things using Toolkit. So with that, I wrap up my session, and I hope you all found it really interesting. Any questions? No, it only supports VS Code as of now. Awesome. I guess no other questions. Okay, thank you all then.
I'd like to thank Mr. Jones for your wonderful session on AWS Application Composer. And now I'd like to request Dr. Velmurugan sir to present Mr. Jones with gifts. Thank you for joining us, sir. And I'd like to invite Abhinay ma'am to the podium for a small memento from our side. And I'd like to thank her for accepting our request to present at this event at the very last minute. Thank you. Please. Thank you, ma'am. So with that, the first phase is completed. We have three speakers, and now we can head outside to network. And we have arranged for lunch as yesterday. The lunch is for industry professionals is at first floor, and for student participants, it's at our mess hall. Thank you.
Hope you all had great lunch. I am elated to invite our next speaker, Mr. Sri Harsha, who serves as solution architect at Amazon Web Services. The title leveraging his experience of over a decade in data analytics is easier to deliver the next electrifying address about generate machine learning and data analytics. Welcome you, sir.
Thank you so much. I know it's post-lunch time, but I'll try to keep you as attentive as possible, right? So I'll do my best. So as I said, hi, I'm Sri Harsha. I'm kind of associated with AWS for more than 2 years now, overall 18 years of industry experience, and my primary job role is to help global enterprise customers to go forward with their AWS journey, right? Whether they are doing something new on AWS, building something new on AWS, or moving their applications which are running on-prem to AWS, right? So this is my primary focus. So today, as I speak to most of my big customers, right, enterprise customers, so the sense what I get is we are almost standing at the edge of another era of technological revolution, right? So the relationship between humans and technology is unfolding like never before. So I don't know whether you have experienced it. So I did my graduation in early 2000, right? And then that was a time of internet revolution. So after that, the second one started, like when AWS publicized their cloud, right? So now we are seeing the third one, which is in the form of artificial intelligence and machine learning, right? Having said that, so two things are very important, right? One is AML. Second one is to become success with AML. So you need the data, right? So people say data is the next gold. So that's why I thought, why not club two topics together and then give a quick perspective of how to do data analytics with the help of AML. Okay, makes sense? So just a quick pulse check before I go to the next slide. Like, how many of you have been at least used AWS? If you can quickly raise your hands. That's very encouraging. How many of you have used some of the analytical services of AWS? Nice. I know, and you would have started. So analytics is my specialty area. So that's why I chose to speak about this topic. But I mean, I just want to get this pulse check because it helps me to go how much in detail, right, when we go through that slides. Any guess, as a individual or a human being, like each individual human being, how much of data they are producing per second? It's 2 MB per second, right? So almost whatever the data was getting generated 20 years back, so we are generating that in an hour. And that's that fast the data is growing. And data, the sources of data is not constrained to one or two places, right? Whether it is your mobile devices, social network, or the applications running by the enterprises, whatnot, right? Your vehicles, so everywhere, right? So if this much of data is getting generated, right? So how do we really deal with the data, right? So that's not an easy task to do. So traditionally we have seen, if you had a chance to work with any of the organizations, so they will have something like data warehouses where they keep their curated data, right, which is very helpful for them to run certain analytical reports and then get some insights about that, right? But with the pace the data is growing and the different type of data we are getting, right, it's not just about relational data. So it's like audio files, images, right, unstructured data, right, videos, chats. So how do we really manage that data? The traditional way of managing data will not help at all, right? So you can't just manage with the way you can just use one place like data warehouse, traditional data warehouses, and then do the analytics, right? Second is the scale. Can you really scale to an extent that if the data grows exponentially with events like COVID or any other thing, will you be able to manage that, right? Third is how do you get the centralized governance? Who is accessing the data? Whether your data is discoverable? How do you really find the data what you're looking for, right? So these are some of the challenges with the data growing, right? So that's why in AWS, whenever we deal with any of the data analytics design, so these are the 5 pillars we try to follow, right? If I have to touch upon few of them, one is like scalable data lakes. So whatever is your data source should be able to scale virtually to any extent, right? And then it should be in kind of serverless form. You don't need to worry about how much of compute or storage I have to allocate to that. So it should be able to extend automatically, right? And security is the most important aspect, needless to say. Even as an individual or an organization, everybody wants to keep that as a top priority, right? And this is in our DNA. We want to apply machine learning in everything what we do in Amazon or AWS, right? So these are some of the pillars we follow when we deal with AWS analytics. Just want to quickly touch upon Lakehouse architecture, not to overwhelm you with a lot of details on the technical side, but to give a perspective, right? So as I said, traditionally you might have seen organizations storing the data in just a curated data and data warehouse. So now that design may not fit, right? So that's why the Lakehouse architecture is the way to go. It has the central component, which is like S3 data lake, where virtually you can store any type of data, any amount of data, and it is supported by other databases which are purpose built for specific data. So for example, you want to store NoSQL data, so you can store it in a particular database engine. You want to store your text search type of a data, you will store it in one particular database engine like Elasticsearch, right? Or you want to do your big data processing, right? So you will use Amazon Elastic MapReduce, right? So like this, you have all these purpose-built data sources with centralized governance, right? So that's what this Lakehouse architecture helps you with. So from one common place, you see like who is accessing the data, to whom you want to give the access to the data, right? And then what they're doing with the data, right? And lot of organizations, big organizations like JP Morgan or Goldman Sachs or PwCs of the world, right? So they have gone ahead, and then what they have done is they have created a data mesh architecture. So they have connected multiple lake houses into one. If I want to give an analogy, let's say there is an organization which has got like 5 line of businesses, right? So what they can do is they can have each of them can have their own data lakes or lakehouse architectures, and then you connect each of them to make it as a federated data lake, right, or a data mesh. So that's how the data is being handled. In the lakehouse architecture, I just want to quickly touch upon one of the key component, which is your data warehouse component, right? So Amazon Redshift is AWS service, which is a cloud native data warehouse, which gives you 3x the performance of any public cloud data warehouse comparatively, and it gives you massive MPP, right, massive parallel processing option for whenever you run any queries. Plus, you can really extend the compute and storage of this data warehouse independently, right? Need not together, right? So for example, if you add a server, normally it's like your memory, your CPU plus storage, right? So in Redshift, you can literally, if you want to extend only your storage, you can do it. Or if you want to extend only your compute power, you can do that separately, right? So that's the flexibility you have. The third is, so data warehouse, right? Normally, what type of data you keep it in data warehouse? So it's your curated data, which you run, where you run your analytics, right? All the queries with the recent data, maybe your last 3 months or 6 months data, which is more critical for your organization or business, right? But the beauty with Redshift is you can actually, you know, join the data which is present in S3, your historical data or archive data in S3 with Redshift by running Redshift Spectrum, right? So these are some of the capabilities of Redshift. And who are the people use these analytical services, right? It can range from data engineers to data administrators. So data administrators are the one who basically manage your administration of the database. They look into that, how do you allocate and then manage it, right? Operational side of it, right? And you will have data analysts so who will run some ad hoc queries and then get some insights, and then you'll have data scientists so who play with the data, who want to predict like what's working well, what's not working well with your organization business. And then you have your BI professionals, like who create dashboards and then see what are the key performance indicators, right? And then present it to the business and then see like what actions they have to take. So you got these are the personas using your data warehouse, right? And those people traditionally would have been like happy with the way writing the queries and then pulling the reports or whatever they were doing, right? But this tectonic change happened with the data, so they can't simply do all those manual things what they were doing it. So they have to leverage ML wherever it is possible in their day-to-day life, right? So these are the benefits, as any of those personas I mentioned. So they get it, right? So improve the business and improve the time to market, or any recommendations they have to give to their customers, improve the customer experience, all these things, right? And some of the use cases which you normally deal with when you use ML, I have just listed. I don't want to go through this. You can take a look at it, right? So it is across the industry. So from fraud detection to stock recommendation to financial planning, to see like whether in the healthcare industry whether a particular drug is working or not, right? So everything, right? Having said that, all these personas, even though they want to use ML, they find it difficult because it's a hard skill to attain, right? I mean, I'm sure a lot of you would have started learning machine learning, right? And you would have realized it's not like a simple programming what you would have been like doing all these days, right? So because first of all you need to know languages like Python or R, and then the overall machine learning process, ML workflow is very complex and iterative in nature. First you have to prepare the data, then you have to cleanse the data, and then you have to choose what algorithm to use, then you have to create the model, right? And then you have to train the model and then see whether the model is working fine or not. So then what you do again, you have to deploy the model, allocate the infrastructure to run the model, and you can't simply leave it there. And then you have to see your model performance over the time, what is happening with your model, whether it is predicting it properly or not, right? If you see the people whom I spoke in the previous slide, they are basically kind of comfortable with SQL. Can they really do machine learning with all these steps I mentioned? Probably not, right? So that's why, so this is our mission with AWS. So we want to simplify machine learning, right? So we want to give the power of machine learning to the masses, right? So why do we say that? Because we at Amazon, we got a experience of more than 25 years working in this domain, AML domain, and we have seen more than thousands of customers how they are using AML, and then across the industry, and then what are their use cases, right? So that's why we want to make sure we simplify this process and then equip everybody, right from developer till the DB administrator to analyst, to use ML. So as I'm talking about Redshift, let's see how you can use ML within Redshift context, and then what kind of integration Redshift has with ML, right? So it can be as simple as, instead of doing all those steps what I showed in the previous slide, it can be as simple as you just write a simple query, right? A SQL statement which can create which can fetch the data what you're looking for, and then it can talk to Amazon SageMaker. Amazon SageMaker is our ML service in AWS. So it can Redshift can talk to Amazon SageMaker. It can train the model. It can see how the model is behaving. Then once the model is ready, it can deploy the same model back to Redshift. So you don't need to worry about what algorithm to choose, what model to choose, how to prepare the data, everything. And you don't need to move the data. So data is just stays in Redshift itself, right? And once that model is deployed, right, you can just run your inferences by calling that function. So if you see, the SQL statement has got like broadly 3 sections. One is the data you're passing, right, like age, zip code, or monthly spend, something. And then it has got the target label, what you're trying to predict, and the function name, right? So that's the function name you will just call when you're doing the inference. So isn't it like very simple compared to what we saw in the previous step? So just write a simple query and then you can do that. The other option is, one is you let Redshift to choose automatically to talk to SageMaker and then decide on what model to use. Second is, if you have your own model, let's say you have got enough experience to create your own models, so you can use that and then ask Redshift to use that particular model. So both flavors are available. So these are some of the benefits if you do it right. As I said, it's very, very simple. So you don't need to know the ML background at all. Second is it is secure, right? And you are not compromising on any of the Redshift securities principle or any database security principle, right? So your data stays there. Nobody is going to access the data, and then it just gives it to SageMaker and then creates a model for you. The important thing is the cost, if I want to touch upon among all this, right? Because where the cost advantage will come is, so a very fractional amount of cost is required to create the model, right? But the most of the cost goes when you run the model and then to get the inference every time, right? Because so you train the model maybe once in a while, and then but the inference it has to run all the time, right? 24/7 if that's the kind of business you are in. Then if you are using Redshift ML, you don't have to pay anything for the inference, because you are just using the allocated Redshift database itself. So that's the advantage of going with Redshift ML. So this is one of the testimonials we have received from the customers. So job case is one of the customers who helped, like very similar to Naukri here. They got millions of open job applications, and then they try to match that with the job openings in their database, and they had a list of so many analysts, and then all those things, whatever they were doing it manually. So by using Redshift ML with all the data they had as an organization, so they can really reduce the cost and then improve the operational efficiency of it. Second thing is, like now in the era of generative AI, right? So LLMs, like large language models. So no conversation ends without touching on GenAI or generative AI, right? So now we got the integration with those LLMs as well, right? So if you want to run any of your large language models on SageMaker Jumpstart, so that's a unit of SageMaker where you can run your foundational models. So you can deploy that those models there, and then you can actually integrate Redshift with large language models running on SageMaker Jumpstart, right? With this, what are the use cases you can really target? Something like text summarization or text generation or text classification. So these are very common use cases, right? Because you have a lot of data sitting in your data warehouse, and then call those LLMs and then get the inference, right? All that is possible because Redshift has a particular type of data type which is called as super, which is semi-structured data type, and then using which you can pass the parameters and get the inference. So you can explore more on this. I don't want to again deep dive too much. Important thing is you have access to the LLMs from Redshift, right? Next, next thing is, like if you are an analyst or a business analyst or a data analyst, obviously you'll be writing very complex queries, right? It's not like a simple join queries or a select queries what you run in your application, because you have to really join the data across multiple tables, multiple databases, get the overall result, and then get the inference what you're looking for, right? And whenever you write any complex queries, you first of all, to put the logic itself, it takes a lot of time, right? Second is, if you're not getting the required result, you spend so much time in debugging those queries, right? So how do you solve that problem? So that's why we have introduced a new thing called as generative SQL, right? So you just ask for saying, hey, for example, let's say you are in a entertainment industry, right? So give me the list of count of tickets sold in North American region for this particular event, right? And it can just create the query and then give it for you, right? And then on top of that, you can simply say in plain like natural language, saying, can you give me or sort it based on the profits we made, right? Or you can say go one step further and say give me the top 3 values or results for that, right? So this is like very conversational. It's not about just writing simple SQL queries, right? So you can do that with Redshift SQL, generative SQL, and finally all those queries you can actually save it in a notepad or a notebook, and then you can run it whenever you want, right? So it's as simple as that. Then you might ask, like, how does Redshift really understands what query, how to write the query? So what Redshift behind the scenes it does is, it understands your database setup, the schema, the metadata you have for all your tables, and then it generates these queries and then gives it to you, right? And again, without compromising the security, right? So, and you can also give feedback to the queries it is generating and then improve the accuracy of it. So that's why someone has famously said, right, what's the hottest new programming language now? It's not Python, Java or anything, it's English. Because so how in a better way you can give the prompt to all these models, so get the better outcome, right? So that's why it's very important to know, like, what prompts to give whenever you're calling any of your ML endpoints. Okay, so we just spoke about the data warehouse, right? But in most of the cases, in many cases, what will happen is your data may not be present in data warehouse at all. So a lot of your data might be still present in your transactional systems, right? So getting that data from transactional system to data warehouse itself is a big ask. You have to write your ETL pipelines, which is like extract, transform, and load pipelines, where you go and read it from every data source, transform the data, and then write it into your database, right? And most of the times it runs in batches, like over evening or nightly batches, or as a micro batch, once in 15 minutes or 1 hour or something like that, and then you get the data. But let's say you want to do real-time analysis. It's like as and when the data changes, you want to run your analytics or analysis. How do you do that, right? So with the traditional way of doing it, it is just not possible. It's very, very difficult, right? Because you have to create those pipelines to get the data from multiple sources and then get it. And many times what happens is there'll be duplicate data sitting in different places, the same data sitting in multiple places, right? If at all, I have to give one important thing with respect to sustainability, right? So you all know how everybody is becoming aware about sustainability and the carbon footprint and all that, right, nowadays. So if you just leave 1 TB of data unused within a system for 1 year, so it takes 50 trees to be there for 3 years to neutralize that carbon footprint. So it's that much of energy or spend you have to do if you just ignore 1 TB of data, right? So that's why you have to deal your data with very, very carefully, right? And the data may be present with in multiple formats, right? It is just text, videos, as I said, audio, different things, right? So now how do you really deal with that, right? So can I get rid of my ETL pipelines? Yes, in certain scenarios. What you can do is you can leverage the power of zero ETL, which AWS has introduced from last couple of years. What you can do is you can create some simple configuration from your actual data sources to your analytical databases. It will move the data within real time. Within seconds or milliseconds, you'll get your data from your sources to the analytical databases, whether it is being Redshift or OpenSearch or S3 or anything, right? So that way, you move the data quickly and then archive it from your main source databases. So that's one way of doing it is. So it's very, very simple. Zero ETL is very, very simple. It gets you real-time access to real-time data, run your dashboards with the latest data available with very, very simple configuration, right? So you don't need to write your pipelines or manage it. Okay, so there might be still certain scenarios where you can't move the data. You have to still keep it in your transactional systems, right? So let's say you have your transactional application running on top of relation databases like Aurora, right? So Aurora, I'm sure most of you might be knowing it's a relation database on AWS with Postgres engine or MySQL engine. So it does gives you read replicas, automated patch management, OS upgrades, backups, right, whatnot, right, everything. So it's cloud native. So if you're running your relational database on Aurora, so what you can do is you don't need to again move the data from Aurora to Redshift or any other data warehouse. So you can run your ML predictions directly on your Aurora itself. Very similar to what we just discussed in the with Redshift, right? So it's simple, it's optimized, and also very secure. So Aurora gives you three options. One is it has got integration with SageMaker AutoML. So what is SageMaker AutoML? So what SageMaker AutoML does is, so once you give, it basically prepares the data automatically, it discovers the data, it prepares the data automatically. Understanding the data, it shortlists what algorithm will work for the use case you are asking. Next, what it will do is it trains the models using those algorithm, and then it ranks the algorithm and then checks, okay, which algorithm is giving the maximum performance or the better performance, and then it picks that algorithm and then model and then deploys it for the inference. So that's the beauty of AutoML. Second is Aurora has got integration with Comprehend, right? So with Comprehend, what you can do is you can solve use cases like text summarization or sentiment analysis, right? For example, a call center person has received a call and then he has spoken to a customer, and then you can see like whether the conversation went well, or so what was the overall sentiment with the customer when the teller spoke to them, right? So these are the things you can do with Comprehend. The third one is bring your own model. So if you are in advanced stage, you want to use your own model, you can do that as well. So all three options are available with Aurora. So these are like three quick use cases if I want to cover. So one is, let's say you are in a banking industry, right? So it can be as simple as you can, create the trigger, right, for any entry coming into the database. As part of it, you send that transaction to your ML workflow, so that can predict whether it's a fraudulent transaction or not. So based on that, you can take a call to proceed with the banking transaction, or you want to withhold that, right? Second would be, so let's say you got list of, a table where it has got list of product reviews, and you can send it to Comprehend and then see what people are talking about your product listed on a retail website, right? Or what kind of feedback they are giving, how many star ratings you are having for each of those products. Third would be, let's say, if you have the spending customer spend details, right? So you can really check based on those analysis. You see like what's the next product or next thing that customer want to buy, or you want to push some notifications or promotions to that customer. You can do that. So these are some of the common use cases our customers are doing with Aurora ML. So with these, what we could really, clearly realize is, so which is a 6 steps process, what it have been like without the ML integration. So we kind of reduced it to just 3, right? So run the query, create the model, and then run the inference. It's as simple as that. And then this capability is not just restricted to data warehouse or relational databases, right? So I'm sure like you might have explored graph databases, right? So graph DBs are very helpful when you are querying some complex relationships. Particularly, in the case of the popular use case would be the healthcare, right? So if you are maintaining the medical history of patients, so you can create those knowledge graphs using graph DBs, right? And then see like what kind of medication the patients are going through. So what kind of drugs or he is taking. So what is the impact of those drugs to the patients, and if a particular drug is released, so how all those patients are reacting. So all those complex relationships can be tracked using GraphDB. I mean, another classic example would be your social media network, right? So with whom you are connected with, right? What kind of messages or the stories you are liking, right? And based on that, we can decide on, or an organization can decide on what to what kind of suggestions we have to provide to the user, right? The third would be like customer 360 degree, right? So if you're a banking customer, right, a bank can decide on see on what are the products you are buying, and then what you are searching on their web page, and then what to suggest. So everything works with this GraphDB. So Neptune is our GraphDB solution, and then we got Neptune ML, which is integrated within Neptune to run those analytics as well using machine learning. Recently in 2023 reInvent, we launched Neptune Analytics, which can really, you can get the results for billions of relationships or the node-related nodes with edges in seconds, and you don't have to move the data. Whatever the data is there available on Neptune DB, so you can run the analytics on that. So you can basically, what I wanted to convey is you can run those analytics on not only on relational data warehouses and also on graph DBs as well. Same with the document DB. So document DB is it's MongoDB compatible, which is NoSQL databases if you have, right? Where your schema might be evolving. So right, it's not very restricted. So your schema might be evolving, and then you are running some aggregations across, right, complex aggregations. So that's where the document DB coming to picture. And then document DB again has got very native integration with SageMaker Canvas. SageMaker Canvas is again no code solution on SageMaker. Let's say you want to do ML, it has got access to more than like 100 or close to 200 transformation. Just do drag and drop. You can do the data cleansing, you can deploy the model, run the model. So all that is automated with SageMaker Canvas. So document DB has got native integration with that, and then you can run that in NoSQL use cases. Okay, so from running the queries from the database layer, let's go little higher, right? Or which is your as a BI user. So what's the normal day-to-day activity of BI user? So they create dashboards, right? They get some insights about what's happening with the business, right? But do you think it's an easy job to create a new dashboard? I mean, first you have to write a query, then you have to come up with this fancy dashboards with color combinations, and then that takes a lot of activity, right? And then you think if the business is changing very quickly, you have to keep refreshing these dashboards, and then you have to work with it, right? And then you have to set up some really good alerts and all that, right? So how do you do that, right? It's not an easy job if you are using a traditional BI tool. So that's why we have QuickSight, which is Amazon's AWS BI offering. You can really scale up to thousands of users within minutes if you are using QuickSight, and you can do it very securely. And then we also have got something called as Spice, which is a caching layer, more than 100 GB of data. You can run it for super fast queries. So all those things are available. But the beauty of Q with QuickSight is Q is our generative AI assistant integrated with certain services. Now we are planning to add that into a lot of AWS services going forward. So as of now, it's available on Redshift, QuickSight, SageMaker, Glue, many other. Okay, so with Q on QuickSight, what you can do is instead of you sitting and creating the BI, these dashboards, so you can simply ask, hey QuickSight, can you just create me a dashboard for the revenue sales we had, revenue we got for the last quarter, right? And then give me a pie chart, right? And then if you don't like it, you can say like, hey, can you convert this pie chart to histogram, right? Or you can simply say, what are the factors really contributed to the profits in the last quarter, right? So automatically what QuickSight can do is it can go to your data source and then create these dashboards and then give a storyline why really it happened with all the factors and the reasons, right? Let's say you got a meeting with your board, right? And then you want to go and present, a particular, like, what are the factors really contributing to your more sales in your product area, right? So you can just ask for the story and then QuickSight and create it and then give it to you. So you don't have to sit and write that, right? So it's as simple as that with the natural language, right? How does, another important thing with QuickSight is it understands the domain language, right? For example, whether you are in sales or in finance or HR, right? It understands those specific entities, what you say in that domain, and also the industry wide, whether it is healthcare or finance or telecom or manufacturing, auto. So it understands all those common language. So when you query with natural language, so QuickSight can come up with the result. Okay. I'll go a step further. I'm not sure how many of you know AWS Clean Rooms. So we released it in 2022 reInvent. So this is basically, let's say an organization want to share a data with another partner, right? Example might be an airline industry, right? So airline industry wants to share their data to a marketing company where they want to run some promos or some loyalty programs and all that, right? So obviously they don't want to give the data, their actual customer data, to the partners, because they are very much worried like if they misuse with that. So what they can do is, instead of sending the copy of data, what they can do is to quickly collaborate. So they say data present in so and so databases, these tables on these columns, just share it with them to this partner on AWS, right? So they can give that access, that kind of access on Clean Rooms. So that's what released last time in 2022 reInvent. So now with AWS Clean Rooms, you implemented ML. So with that, what will happen is you don't need to actually share the entire data. So you can simply share the subset of data and then make, what AWS Clean Rooms ML will do is, with a subset of data, it generates a similar data for a broader range and then shared with your partner. So behind the scenes, it creates the required data what your partner is looking for. It creates a model and then generates the data and then gives it to them. So that way your data is very safe, but the purpose is served, right? So that's another way of doing it with Clean Rooms. So before, last 5 to 10 minutes, I just want to quickly touch upon the generative AI part with the integration, how we really do with the patterns of consuming generative AI models, right? So the common models in the market, whether it is GPTs of the world or Hugging Face or Claude or Anthropic models, right? So these are the models available in the market, right? And there are multiple ways to use it. Like if you have the skill and the money to create your own model, you can really do that, which takes a lot of effort, right? Because literally these models are trained on the internet data, all the data, most of the data available on the internet, right, with billions of parameters, right? So that takes like huge amount of time, compute, and money to do that. So that's one way of creating your own foundational models, right? The easier way is if someone has created it and then you simply go and use it, right? So that is like using prompt engineering. So ask for it and then you get the response. Like I'm sure most of you have used ChatGPT. Just ask and then it gives you a response, right? But many times what happens is you get hallucination. So you're not sure whether it is giving the right result or or the right response or not. It simply doesn't say, like, most of the time it doesn't say like I don't know. It simply gives some answer, and then if you're not aware, like, you will accept it, right? So that's called as a hallucination. The another way is customizing it, right? So you take the model, so as an organization, so you train the data with the train the model with your data you have, your domain specific data, right? So that also again takes some effort, but it doesn't take as much as creating a new model. Most of the now with the current environment, what we have seen is most of the customers are going with a RAG pattern, which is retrieval augmented generation pattern. So which I'll just touch upon in the following slides. Before discussing about RAG pattern, so let's understand what are embeddings, right? So what are embeddings? Embeddings are basically representing your data in the form of vectors, right? So for example, because most of these ML models, they understand numbers, right? So they work on numbers. So if you convert your data in the form of numbers, so the results can be more accurate, right? So that's the whole idea of coming up with embeddings, right? Or the vector embeddings with m cross n dimension, whatever you are looking for your accuracy and the computation, right? So how do you basically create the embeddings? So there are certain models using which when you give the data, it creates embedding and then gives it back to you, right? So why do we really need embeddings, right? Because whenever you store the data in the form of embeddings, it keeps the related data close to that particular vector. For example, when you store both tiger and cheetah, so they are kept nearby than a buffalo, because the tiger and cheetah belong to cat family, not the buffalo, right? So something like that. So even though all of them are kind of animals, right? So that's a context. Similarly, let's say if you are a fan of Kishore Kumar, you say like all the patho songs of Kishore Kumar are kept close by than any hip hop song, right? Something like that. Right. So that's the beauty of embeddings. And when you do similarity search, so you get more accuracy when you do that, right? And so basically, once you create the embeddings, so you need a place to store those embeddings, right? How do you do that? So that's where, so we have engine called as OpenSearch Serverless. You can really, you make use of it, because why OpenSearch Serverless is, I mean, if you're aware, OpenSearch is already used by like large amount of customers for doing the text search. So if you can store the embeddings also in OpenSearch, it becomes very easy for them to solve most of the search related use cases. Having said that, this is not the only database available. It's not the only database available to store the vector embeddings. So you can make use of, we have added support for DynamoDB, we have added support for Aurora Postgres, but OpenSearch is very, very popular because you have the serverless option. We don't need to really maintain or manage the environment at all, right? So, and it can scale the compute and storage independently. So that's another advantage, right? So RAG has got 2 steps. Okay, first, obviously, you have to create the embeddings, right? For any data you have to create the vector embedding. So what you have to do is, first extract the data from your different sources, call a particular dense vector encoding model, and then it creates embedding and then stores it into your OpenSearch vector database, right? So that's the first step. The second step is you query that database, which is OpenSearch, where the embeddings are stored, and then get the result. If I have to give one example, might be, let's say you are running a travel company, right? And then you have all the data of the tourist destinations, like what all activities you can do there, right? So if a user searches, hey, give me a list of places near Himalayas where I can do skiing and then camping for 2 days, and what are the pros and cons of each of those services, right? It has got so many, within one query got like so many queries, right? So what you can do is, they are not clearly telling what exactly they need. So your text search will not work in that case because there is no text match. So what you will do is, in that case, you convert that query into embedding first. The query itself will convert into embedding by calling a model in step 1. So once you have the embedding of your query, so you send that to your OpenSearch database where you already have your the data, business specific data. Now you get the matching and then call the LLM, whether it is GPT or Claude or Anthropics of the world, and then summarize the result and then send it back, right? So even though multiple steps are involved here, so once you have the embeddings created and then you have the models to run your vectors, it's very easy to come up with really great user experience rather than doing just a simple text search. Right? So another thing, I mean, I just want to give the way organizations are moving, right? So there is now the concept of hybrid search is becoming very, very popular. So hybrid search is basically combination of both lexicon search and semantic search. So vector embeddings, what we just spoke, is the semantic search, right? So for example, vector search works. I mean, if I have to give another example, is suggest me a cozy place to sit, right? So they are not telling what they really need, but when you if then when you go and search it on Amazon, it suggest you a sofa or a couch or a recliner, right? So how does it understand? Means because it knows what is the context of that query, right? If you text search would be like you will look for specific, right? So give me mobile phones less than $20,000, right? So that's a very specific text search. So with hybrid search, what you can do is you can combine the power of both text search and vector semantic search, right? So only thing you have to handle with that is the weightage of the results for both text search and semantic search may not be same. So you have to normalize it and then you have to use it. Again, it's a next. I mean, it's not a very simple process, but yeah, obviously, like you can do that. So if you are able to crack it, then your results are like much better, and then you will be more accurate, right? So with this, like kind of, I wanted to give a overview of how you can run or integrate ML with your, whether it's data warehouses where the data itself, data is present, or how you can get the data into or run it on multiple different type of engines, right? Whether it is NoSQL or Graph or anything. Third is how we can integrate and then run your ML with analytics by integrating with LLMs, right? And the fourth, it need not be on just on databases. Even if you are a business BI user, so you can make use of the power of generative AI. With all this, like I just want to summarize. World Economic Forum report has said more than 75% of the companies, right, will start using AML in next 2 to 3 years, right? And McKinsey report says around $4.4 trillion worth of business can be unlocked with using ML, right? So and we are in a kind of technological or a learning revolution, I would say, right? So things, skills like ML or machine learning or artificial intelligence are always there. These are hard skills, so it's important to learn. But the more important would be like how creative you can get, how quickly you can adapt to the changing situation. So that becomes the key, right? So that's why we at AWS, we try to bring in any changes happening in the industry to embed in the service what you are using in AWS, right? So we have a leadership principle within AWS, which is like learn and be curious, right? So the learning never stops. So I hope in these 45 minutes I was able to share some of the insights which you will take back home, useful, and also I would like to thank SGIT and other organizations, coordinators who gave me chance to come and present here. Thank you so much, and have a good learning for rest of the day. So this is my email ID. So if you want to reach out to me for any other queries, yeah, you can take.
you, sir, for your wonderful address. Now I request Dr. Bala Subramanian, sir, to present our esteemed speaker with a gift as a token of our appreciation. Our concluding speaker for the day is Mr. Giri Venkateshan. Serving as a developer advocate at Solace, he is a master of event-driven architectures, inspiring people from all around the world. He is admits us to present a session on orchestration and the event-driven architecture.
Check, check.
You guys heard enough of AI for the past 2 days. Something crossed my mind when you were talking. When I was a kid, when a teacher asked me a question, obviously I'll be wrong, right? So the teacher will say, "You're wrong." "No, sir, your question is wrong. You didn't ask the right question for my answer." That's what I wanted to say. But today, if you look at ChatGPT and all these AI interactions, see what's happening. So, bottom line is, in ChatGPT, if you are not satisfied with the answer, you go back and tweak your question. What have we come to? Programmers and AI programmed people, right? Because we spend so much time talking about how to get this prompting correct. And I was surprised when I heard this term prompt engineering. I'm like, what? Like, I mean, not in a jovial sense, but seriously, things are moving at a breakneck pace. I have no clue where it's going to go, right? What's going to come in tomorrow, day after, and then you guys, university level, college level, are doing a wonderful job. So let's see where it takes. But I'm not going to talk about. Just a second.
Check.
Okay. Hello. See, I'm not going to talk about AWS or AI or cloud, but they're all integral part of everything. So there'll be a kind of a mix of sprinkle of things. So my name is Giri Venkatesan. I'm an architect and developer advocate with Solace. Solace is a Canadian company based in across the world. We have offices, and we are specialists in bringing out real-time enablement to enterprises. Okay, it's all about event-driven architecture at a technical level. So enough about me. So my topic is a lot of words. Okay, the key thing is design, architecture, and the event-driven paradigms. That's what I'm going to be focusing on. And in that, cloud becomes a very critical instrument, right? So let's see where it takes. So we're going to peel the onion. Let's go back in time. Let's look at how computing evolved, where it started, and then what is the role of event-driven architecture, how did it come into existence, and then talk about this whole notion of distributed systems reinvented with cloud, right? And lastly, close out with some architectural paradigms that we can take away with us. Okay? First one, it's all oops. What? Oh, I had to be close. All right, so basically the computing has been a very transformative journey. It's not like it happened yesterday. 20th century or even before the pre-millennia, people used to use the abacus to do some basic math. and then paper-based, and then fingers. You know what I'm talking about, right? So from there, we came into the mechanical, electromechanical, digital. Now we are going towards quantum. So it's been a transformative journey that has revolutionized the way we think, live, work in 100%, in every sense, right? And what's coming tomorrow, it's even more impacting, especially AI, ML, deep learning, and so on, okay? So, I'm sorry, this is jumping. Let me try. What's happening? Okay, so the point is, it started with Abacus, and then we came up with this electromechanical device, the Charles Babbage's analytical engine. That's early 20th century, where we were able to program something called as computers. And then mid 20th century, we started with electronic computing, right, where we had digital computers, probably this building size, room size, cabinet size, table size, very big. IBM, Xerox, and all those guys. And late 20th century, which some of you may not know, we know, network computing, basically personal computers, and then internet came into existence by connecting multiple computers and so on. And today we are looking at a scenario that's called as ubiquitous computing. That's nothing but 21st century, just the 20 years of this century, right? We are talking about anything we do, it's mobile. Anything we do, it's cloud-centric. Anything we do, analytics, right? And it didn't stop there. We were so happy. 2015, 2016, the domain kind of settled. That's great. Let's go and solve problems. No, there's a different way of doing things. Here comes the AI, edge computing, quantum computing, human-computer interface, IoT, right? It's never stops. These are the emerging technologies that's going to impact now, because some of the things that we're talking about, you can see students having projects in them. That's amazing, right? So this will have an impact now, tomorrow, and possibly whatever comes day after tomorrow. We don't know, right? With that said, let's focus on the digital computing, right? When I made a statement, the primary purpose of computer was to solve problem for us, right? So that means build a service or an application and then run it on the system, and it produces an output. We're happy. Oh no, I want to connect two computers and utilize their power. Maybe the CPU cycles, maybe the storage, right? And no, I want a bunch of computers connected. That's great. I mean, that's logical extension to your thought process. But technically what happened is, how do I allow information exchange between these computers, right? So initial days, we're going to put a file server. Whatever I want to say, I'll drop a file. Whatever I want to read from, I will read a file. Bottom line is, the critical need is the ability to pass data or information between the systems, so that you create a unified view for these applications to act upon, right? And second one is being able to trigger something on another machine or another process to start a job or kill a job or fire something, right? And last piece is, we wanted to do everything in scale. That's the necessity made us connect computers to work together. Clear, right? So if you look at it, as I mentioned, file-based mediation. I'll send a file and you keep looking for a file. That was the early days. And then next came, no, we'll use database. I will have a record dropped in here, and that record will trigger something, and you will get called. That didn't work either. And then network, basically the sockets. Tell me where you are. I'm going to make a connection to you, and I'll maintain the connection forever living, and I'll keep sending data. You keep sending me data to bidirectional communication. Happy. This is great. That's the reason why we have the internet today. And it didn't stop there. Post-internet, we have application domain where everything is web-based, internet-centric, right? That's possible because we developed application protocols like REST, right? We didn't stop at TCP. We moved to HTTP. Then came MQTT. Like that, the protocol level evolution happened. Parallelly, these are all at a lowest level. At an application level, now that we have built monstrous systems like ERP, CRM, SCM, right? How do these applications talk to each other? Of course, they will be talking sockets, but can there be a better abstraction at a higher level? That's where this notion of middleware came in. That domain is called as integration. application to application communication. That means an SAP would be able to talk to an Oracle system using their native OCI, Oracle interface. Similarly, the Oracle side, an adapter would be able to talk to SAP using SAP ABAP document or whatever, right? This was the domain where we thought integration is conquered. Now, every application, every service can talk to each other. But time came, we said, let's split this problem into two parts. The first part is the business data, right, that you want to exchange. That could be an action, or that could be a command, or that could be a payload representing a state of a record, all right? Distributing this data over the network is a distinct problem than being aware of who's the consumer, who's the recipient. Should I do data transformation? Should I do protocol transformation? That's a second problem. So you split these things into two pieces. You clearly know you are talking about a distribution problem. That distribution is all about routing information to the right recipients in real time. That's where the event brokers as a concept came into existence. So far so good? You guys are able to follow? Right? Okay, now it's time to introduce this event-driven architecture. What the heck it is? It's pretty straightforward. We all know. After reading this, you will know. It's an asynchronous communication. I mean, hopefully you know what's the difference between synchronous and asynchronous, right? It's an asynchronous communication between applications. Now, we are not talking about client, server, browser, none of those things, simply applications. We are publishing and subscribing. This is a new term that we all need to get used to. If you use API, your terminology is pretty straightforward. Requester, replier, sender, receiver, right? Client, server. So there's always a kind of a half of a full circle, right? But over here, we are talking about a different mode where you're publishing information and you're subscribing to what you need, right? Over an event broker. Just make a note of these three words. They make a fundamental difference in terms of how EDA stands out from rest of the things that we know today. In this big picture, an event is a central kind of a float, right? It could be a signal to a change in the application, or an action or command to be executed on the other side, all right? So event broker is a central piece here. That's going to be the mediator, allowing these publishers and subscribers to connect to and then engage in an asynchronous communication by passing events. Clear? Now, what are the benefits? Why do we need this? It is about time we need to have these things. I will explain why later, but the benefits are pretty straightforward. The decoupling, you know, if you come from a software background, one of the fundamental things that you'll be learning in your thing is coupling, cohesion, right? So the coupling is a bad thing because you need to know everything about the other application, starting from location to location meaning network address, to what protocol they speak, what language that application was written in, and so on. We need a decoupling, right? So with decoupling, we become transparent to each other. You can be I'll talk about it more later. And then the scalability. I mean, that's been the driving force for us from the day one. Even when we talk about AI, cloud, right? We are talking about everything in scale. The days are gone where you build a simple solution for a simple problem. Even a simple problem today would kind of transmogrify into a complex problem, right? So you need scalability. And the next one is reactive. This is the most important piece. If you think about our programming world, everything is based on, tell me what you want, okay? I'll give you what you want. So ask me, I'll give you. Invoke me, I'll respond. Send me a request, I'll send you a reply. Make sense? Let's shift this into a different thought process. Tell me what you want only once. Don't bother me after that. Go on doing what you want. I will send you or tell you when I am ready. So basically it becomes reactive. That condition could be based on something else internally, right? So you set an alarm, right? Alarm rings at 4 a.m. in the morning. You don't go and wake up at 1 o'clock. Hey, is it 4 o'clock? Is it 5 o'clock? Is it 3 o'clock? Right? It is set. When it is up, it will ring the bell. that kind of a reactiveness is what is needed to kind of make the best of complex environments, okay? And resilience, I mean, we don't have to talk about this. AWS is all about resilience, right? So when I am down as a consumer, can you keep my information for me to come back and consume, right? My application crashed, or my network is slow, or I encountered an error when processing something, right? I want scalability. If this network region is down, send it to another region. So the resilience is the key part, which is, in a technical term, translates to guaranteed no loss of events, right? In a REST world, if you understand what I'm saying, REST is nothing but the typical API. You send a request, you get a timeout. There is nothing more to talk about, right? If you get a different status, yeah, network not reachable. That's fine, but you know instantly as to what happened to your request, right? But in a complex world involving events, it's not going to be easy, right? We have moving pieces, multiple moving pieces. And last one is, you might have already observed, nothing seems so simple as it seems. With events, we are talking about real-time flow, right? When you publish, boom, the event hits the broker. When the broker finds a subscriber, whenever it's ready to deliver, it delivers to the subscriber. There is nobody intermediating and then saying that, yeah, now you can publish. Now you can, no. It's all reactive, real time, right? Simple example, a ship getting stuck in Panama Canal. What if you know about it on that instant? As an enterprise business, say HUL or Hindustan, all these big retail conglomerates, they could do many, many things. They can reroute other ships, right? They can update the downstream warehouses saying that this stock is not going to be replenished for 3 days, right? And they can take inventory of other warehouses and start moving things around. Planning, prediction, right? The analytics is all about prediction, but proactive, predictive, right? Those things can happen in a real-time basis. That's where the real-time as a benefit comes out naturally, all right? So we talked about this, what is event broker? This is the intermediary. As a client, be it that you're producing events or you're consuming events, all you need to know is where to connect. And where to connect is your event broker, all right? And you can be there will be only two classes of distinction. Either I connect to send something, or I connect to receive something. So in a general sense, producer, consumer. And then we talked about this decoupling, right? The protocol transparency, agnosticism, right? So that's where you see here. A producer could be sending IoT sensor data using MQTT protocol. And then an application from cloud could be sending JMS messages. And then maybe you have an industry floor sending a different kind of a proprietary protocol information. On this side, you have different set of application, form factors, mobile, cloud, web, right? Or even Raspberry Pi for that matter. All these guys, as long as they're connected to a central broker, they will be able to seamlessly exchange events. And the arrival of events, availability of events is your business, is your workflow. Make sense? Producers and consumers and broker acts as an intermediary that decouples, and this is asynchronous communication. Very, very important from being some of you are students here. Synchronous is pretty straightforward. You send a request, you expect a response. If you don't get a response, you get a timeout. So you close it out. If you have an issue with network, you know it instantaneously. You are blocked, right? Blocking interaction. Asynchronicity is all about non-blocking. That means as a producer, I might be asking for the same thing what you would do in a REST API. Hey, what's the price of this item, SKU, right? So I put that in an event, price check, event, and publish to broker. Then I go on doing something else. Maybe I'll send the next event. Or maybe I'll do some background job. I'm not blocked. Broker takes it, finds out who's the one that can respond to this price check. Oh, there is a inventory system. He delivers, and he has a subscription for that. So he sends it to it. When this guy gets it, what does he do? Oh, somebody has come, okay, I need to check. He can take his own sweet time. It could be instantaneous, or let me finish this. I'm not even going into that, right? This consumer can respond to that event independently, which is got no concern from the producer perspective. And when he responds, it goes to the broker. Broker knows that it needs to be delivered to this producer. So when the event comes to the producer, it's like, it's magical. You're not blocked. Both of these producers and consumers can go on independently. Communication is asynchronous. That's the class of difference. If you have questions, block it. We'll talk about it in the end, okay? Okay, so to make it more clear, when you say decoupling, I'm going to dig into it, right? There's a sender, there are two classes of applications, let's say. They want to talk to each other. So the logical thing is, have them create a socket and talk on that socket. Well, there are two more instances coming on board. Now you create this crisscrossed connection so that everybody can talk to everybody. That's the need, right? And then make it 4 more. What you're looking at is a complete mesh. No, really it's a mess. Because these applications could be spending more time managing the sockets, keeping them, up to kind of a business standard, than taking care of their business logic. This is not desirable. This is what you have. When you bring in the broker, all these guys can connect to the broker, especially as a producer or as a consumer, and that's about it. You can scale independently. And decoupling is already clear here, right? This producer or this consumer, they don't need to know who's going to be the consumer. Similarly, a consumer doesn't need to know where this producer is existing, in the cloud or mobile, or you know what I'm talking about, right? And the next one is scalability. That's net, right? There are a bunch of clients. Their role is they have submitted a job or a price check, and they kept asking, are you ready to give me the answer? Are you ready to give me the answer? Are you ready? Are you ready? Are you ready? That's what you see. What if you have 100 clients, 1,000 clients asking the same question? Today, that's what you do with REST. Remember, if you get a timeout, maybe you throw an error or you retry. When you retry, you're hitting the server. So there's a load is going to be quadrupling. This is a real world scenario, guys. When we have this Republic Day sale, billion dollar day sale, Black Friday sale, what happens to your server? There'll be a team of people working behind the scene to prepare for that, to scale up. Those are all good, but what if you turn this around? Look at the problem per se and then say, hey, when I am ready, I'll publish an event ready. You just subscribe to it. Don't keep asking me. Don't ask me, I'll tell you. Make sense? This is a pattern or model that's fit for scaling, okay? The next one is reactive, which is already you can see here. It's nothing but don't keep asking me. I'll give you when I have it. That's reactive nature of things, right? Instead of everybody asking ready, 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 you will get a ready event when it is ready. Where is it coming from? It's coming through the broker from the source. It could be the inventory check system, or it could be the job system, right? Same thing, you send when you're ready. Oh, there's a key difference you need to note here. Subscribe it to topic ready, right? You are going to say that I need to be notified when my request is ready for processing or completed processing. That means subscribe to this ready as an event topic so that when this guy finishes, he will publish a reply on that topic. So notice that the interaction happens not in terms of payload alone. It happens in the context of this topic. The topic being kind of paired here between this publish and subscribe, they got to be same. You cannot say that it's like there's a mail came for door number 12, but I delivered it to 13. Doesn't make sense, right? So the mail carries the door number 12, and the door number has door number 12. Door has door number 12, and then you deliver it, something like that. So he subscribes to the topic, and he publishes on that topic. The broker mediates this and ensures that right people get the right messages or events, okay? Last piece is resilience, right? One other thing is the moment you come in the middle and take responsibility of this enablement in terms of communication, you can also do a lot more. Simple example, this is a subscriber, a guy is very slow, right? So that means if you don't queue those messages, at a point in time, broker would not be able to send the messages to them. The network would be blocked. So he will start dropping the message, right? Or maybe the other guy is encountered error and he crashed. These are the cases where broker offers you durable subscription, as in, hey, create a queue and then slap in the subscription, the topic subscription that you care about on that queue. So whenever the message comes, it's not going to look for consumers. It's going to look for queues that has the topic subscription. So the messages will be getting enqueued here, and these consumers, whenever they're ready, whether they are slow, offline, online, or crash for 2 days and then come back after third day, doesn't matter. These events are queued for them. This is what resilience is all about. I'm sure it will open up some different questions. How much storage should I allocate? Does it live in memory? Answer is cloud. How much ever you want, keep adding, right? So that's how the marriage of these two things happens. I'll touch upon it later. So are you thinking what I'm thinking you have seen so far, right? So it looks like a standard problem. How did we miss it? No, we didn't miss it. Event-driven architecture has been around for a long time. It just got prominence. I'll also explain why it got so much prominence because of this AWS reInvent in 2022. Okay. Before that, I've been involved in event-driven architecture for more than a decade. You know, I was a original coder of early broker. Anyway, so I see design patterns. How many of you know design patterns, what they are? How many of you have used design patterns? Okay, if not, today exercise, go back and please give it a shot, because that reflects the maturity of the subject that you're dealing with, and then your own maturity in terms of solution thinking, right? Now let me show you what I mean by that. Bottom line is it's a reusable solution to common problems, right? Common problem that repeats itself. And these are basically guidelines or templates, not a solution itself. And there are various patterns that you can see: behavioral pattern, decorator, observer, abstract, but we are going to be interested in one set of pattern that we call as a message exchange pattern, right? We are talking about message. By the way, message and event are interchangeable. So these are publish, subscribe. A producer produces an event, and there are 3 consumers having subscription to that topic, so all 3 of them will get a copy. This is a pub sub, right? And next one is point to point, which we very well know, right? I want to deliver this message to him, maybe by address, by name, by ID, right? So, the next one is request reply. It's not helping me, honestly. Request reply is pretty straightforward. I'm sending something, I expect response back on the context of that request, right? So if you continue this path, there are plenty of patterns that reflects the maturity of what's happening. So with queue, now we talked about this, you know, do you have consumers consuming from the queue simultaneously, or like a failover, only one of them is active, rest is all on standby and goes on a round robin, right? And you also have a special aspect, you know, this is meaningful when you have a geographical need for distribution. You know, an order placed in UK doesn't have to be sent to Singapore, because their warehouse, their processing, everything could be confined in the European region, right? So based on the topic, you can create a key that reflects the source or origin, some kind of key, have them partitioned, right? So these are all for scaling and efficiency purpose. I'm going to get creative here, 1 second. So we saw message exchange pattern, right? The best way to relate to it is like, you know, what is this? Don't tell me Rajinikanth, we know that, right? It's a point to point. He picked up a bullet, loaded into the gun, and shoot, right? But Rajini can do more than that. He's a Taleva, right? Look at it. He picks a bullet, replicates it, loads it on 100 guns, and shoot at the same time. This is your publish, subscribe, right? Just as a joke, but you know, you got the message, right? So it doesn't have to stop at the broker level. There is also a concept of mesh. Basically, you can have a network of interconnected brokers, right? That means a consumer, a producer connected here in a cloud, basically on an iPaaS platform, can publish an event, could be delivered to a broker or a consumer on a data center on a different cloud. Now this opens up Pandora's box. Everything is on AWS, that's a homogeneous cloud. What if this is Azure, that one is GCP, this one is, that's a multi-cloud, right? And then bring in on-prem into the mix. That's your hybrid. Fair enough? So the broker per se should have the ability to exist in all these forms. Okay? So the best way to relate to this is a good example. So there's a, let's take a retail store, 3 forms. One is online, and the other one is a store where you have a point of sale system, take the order, collect the money, and then mobile app, right? We know that. And then when it comes to the real world, okay, it just jumped. So you can see here the consumers, like your financial system doing credit check, warehouse system doing inventory check, and customer service to keep everybody up to date. Now, each of these guys have a specific focus. For example, mobile app could be a stock inquiry or a new order. Point of sale could be return or new order, right? Because it's a store, walk in for return. But all these guys, they publish somewhat events that are interchangeable in a context perspective. So all these order related items will have to go to this financial system and a warehouse and also customer service so that the order gets updated. This is done by having a network of event brokers, because they could be in different regions. It's a mobile app. You can sit here and then place an order in the Europe or Americas, right? And the point of sale could be the local stores. They may have presence in Asia, Europe, and Africa, for example, right? It doesn't make sense for a point of sale system in Africa to get routed to India. So you create this geographical separation or grouping, network segmentation, right? So this network of brokers is what we call as an event mesh that offers that for you, okay? Now it's about time we need to look at what is the role of cloud here. No. The cloud is basically, we know the benefits of cloud. It's pretty clear, with or without EDA, right? The considerations and benefits, pretty straightforward. Scalability, and then the tools and the ecosystem that cloud has offered for us to migrate seamlessly and work backwards also. And then the whole purpose is security and deployment, ease of deployment, right? These are the considerations. If you have to manage all these things today, which we used to in our own data centers, and we had an army of people, system administrators, and data administrators, and so on. Now, when you delegate this to a cloud provider, you're off the kind of overhead, and these are done with absolute class. As Shreya or somebody was mentioning, 99.99999, 11 nines. Who can offer that? How much effort you have to put to get there, right? But the benefits are pretty straightforward. Elasticity, that's the need in every problem, right? Even if you're a startup, you build something, first thing, oh, can I scale? How far I can go? Can I handle 100 clients per second? Well, whether you need it or not, the elasticity has become kind of an inherent first class requirement, right? Next one is fault tolerance. What happens if it fails? Oh, I should have a secondary IP, or I should have a secondary storage. So you want everything resilient, fault tolerant. Network segmentation. This could be for larger enterprises, but that's a logical problem, right? Even for Amazon, right? They are creating India into zones. That's how they treat it. North, south, east, west, and so on. So the warehouse management, billing management, return management happens in the context of a zone, not as a whole Amazon India. So that segmentation can be reflected at network level, can also be kind of reflected at the application domain level, right? And a single point failure. These are all the benefits. Every single application that's considering moving to cloud has these things. EDA is no enemy to this. It benefits from the same. I just want to call out few things. If you look at it, the cloud lately has become specialized in doing certain things, which is impossible to do on your desktop or laptop or even your own data center, for example. ML and NLP processing, deep learning, right? GCP is pretty good at deep learning. NLP is pretty good with AWS on any scale, for example. So why would you want to invest in the infrastructure? All you need is host it on the cloud and find a way to integrate into your ecosystem. It could be on-prem, or it could be again in the same cloud, right? So tap into that specialization. That's one motivation. And then compute-heavy resources. In EDA, also, it's all about computing. When you get something, you're going to spend time processing, right? And then push it to that. And scalability. That's very, very important, because the example that I quoted is Black Friday, Republic Day sale, right? So it could be a microservice. That's what is doing credit check or inventory check. What if that is getting choked? Why not scale that microservice, in a containerized setup to 1,000, 10,000, 100,000. And then when Friday is over, bring it down, right? Cloud offers those things. And not just that, the ecosystem is built with facilities for you. Kubernetes, right? So the last one, it's always good to be closer to the source or the sink. Basically, source where it originates from or sink where it's consumed. We're talking about the applications. If half of your applications are hosted in cloud, you might as well have the broker in the cloud. See what I mean? Similarly, if you have everything in the region, like US 2, you might as well move a broker there. Because otherwise it's network, right? So in real world, this is how your hybrid cloud will look like. An event published on the on-prem system, just because these clients over there have subscription, they get automatically routed through this network of brokers and eventually makes it to the client on any of the interconnected brokers. All right? So I have been very generic about event-driven architecture, but then if you look at it, the features and functionalities and broker that I'm talking about, those are very specific to Solace. Okay? They're also available in other brokers. But when you get a chance, do a compare and contrast or reach out to me. So it's time for me to close out. Event-driven architecture is here to stay. You may not call it as event-driven architecture, but you are already doing it. If you're a UI programmer, remember event, that's exactly the same. In application context, we call it EDA. In a UI programming, be it a React or anything, emitter class, right? Event bubbling, event trickling down, all those things. You built a UI logic around that. Layering, right? So something similar. So events are not new, they're here to stay. And one thing that changed is the popularity. Because right people at the right place make a statement about it, it catches fire, literally. So I'm just going to play this condensed version of this video. I don't know if the audio will come. Let me see. What I showed you is, this is Dr. Werner Vogels, CTO of AWS. Wonderful person, very knowledgeable, chief architect, CTO, all the roles. He is the one who talked about event-driven architecture in such a wider audience in 2022. To demonstrate that, what he showed is people walk into a restaurant, there are 10 people, and you see on the picture, right, everybody moves one at a time because the server, there's only one waitress, and she is serving one at a time. That's the first part of the equation. Let's look at the second part. If you have not seen the video, you might relate to this. Now, she took the order, right, sandwich and fries. Look at it, she's doing one fries at a time. When is it going to be complete? There's not a scalability problem. This is like a starting problem of everything. So this is where it stops. So the point he was trying to make is everything around us is asynchronous, including the nature. The bird murmuration to the grazing wilder beasts running havoc. It looks random to us, right? But there is an order, right? It is asynchronous. But my point is, if that is the case, why not our systems that we build? There are greater benefits of becoming asynchronous. But I'm not saying that dump everything and then make everything asynchronous. That's impossible. At least as of today, it doesn't look like it, right? Because cost and then investment that's already existing. But the point is, wherever it is new, cloud gives you an opportunity for right technology use. The new things that you bring in, put them on event-driven architecture. Make it asynchronous. And then collaborate with the existing one. There are patterns for that as well, right? So with that, I conclude. And if you have any questions, feel free to ask. You can reach out to me. And if you want to engage seriously with the ADA in terms of trial version evolution on your desktop or cloud, join Solace community. You will find all the details. And that's my coordinates. Feel free to reach out to me. I'll be happy to help you guys. Right, any question? Otherwise, how was it? It's not AWS. It was not cloud. So for a change, that's why they dumped me to the last session. I'm just kidding. Hope you took away something. You can become a master by listening to these 5 slides. But please get these words and keep in mind, especially students, when you go back and about it. How am I sending the messages? They're meant to be real time. Do I need a broker? Oh, there's an MQTT broker, Mosquito. So one leads to another. Everything has to get a start. To that extent, I'm happy that I'm able to connect and see some new thoughts, new terms, new ideas. Right, thank you guys.
Thank you, sir. That was an amazing session. It's such a pleasure to have you here with us now. Now I request Dr. B. Senthil Kumar, sir, to felicitate our speaker with a token of appreciation.
So yeah, that's it. That's the end of the serverless track, and we now have a panel discussion at AV Hall 3, the main hall. So please go for a break, and please rejoin us at 3:40.